Hello, welcome there. My name is Darlington Gospel, and in today's stream, basically tutorial, we're going to be diving into Rust programming. Many of you have been asking me of recent for Solana tutorial, and so on. One of the reasons why we want to be very careful how we proceed with Solana is because Solana has a dependency on Rust programming. So if you want to dive into Solana, you need to understand how to develop with Rust programming. Now, the cool advantage of understanding and learning Rust is because it is very applicable to a whole lot of blockchain networks. So that will include Solana itself, ICP, network, they have Rust, programming for their smart contract. You also have Polkadot, which is Rust programming as well. And what else again? We also have Near Network, which is Rust programming. There is so many blockchain network that relies on Rust or language that are very close to Rust. So Rust is a very instrumental programming language when it comes to building smart contract. And now, since we've not actually built programs with Rust on this channel, it won't make any sense for us to just jump in and start building smart contracts. We need to educate everyone on how to utilize the Rust programming language, the concept about Rust. I used to not like Rust at all because it looked a little bit freakish in terms of syntax and so many requirements that is based on it. But diving deep here and formulating the curriculum structure for this particular course we're doing today, I've learned quite a lot about Rust, and I've come to appreciate the language for its true beauty, which is based on performance, speed and reliability. These items, these features are very important, especially when you have to do with low-level language and low-level code structure, such as with smart contracts that compiles to assembly code. So all of these things are the things that we want to discuss and work on in this particular tutorial. So I actually did a little bit of a check for benchmark concerning the performance of a Rust application versus Python application versus Node.js application, and Rust application came up above, like it's faster and more reliant than a Node.js application. The cool thing is that there is a similar approach which you can code in JavaScript that makes it a little bit easy to transition to Rust, which is the use of TypeScript. Now, why is that so? Because TypeScript is statically typed, okay? But wait till you see Rust. Rust is so statically typed that it's very difficult for you to make errors, okay? Errors are very minimized with this Rust language. So there's so many benefit that comes with it. And as a blockchain developer / smart contract developer, you need to understand how to code with Rust. At least if you're going to get two programming language that you need to have in your arsenal, that should include Solidity and Rust, because these are the most in-demand smart contract language. Why I like Rust even over Solidity is because it has multi-facet application. Why Solidity is only going to be applied in building smart contract only on the EVM chain. Rust goes into a whole lot of programming blockchain networks, as you will get to see if you just do a little bit of a research. So if you haven't subscribed to our channel, I'll ask you kindly, please hit that like and subscribe button and smash that notification bell so you won't miss out anything that we're going to be publishing on this channel. So this is the prerequisite for us diving into multiple streams of blockchain networks such as Solana. This is something that we want to do on this channel to bring in Solana development, but we want to understand how to work with Rust. I'm going to take you through this full course, for free here, of course, things that you need to learn and understand about Rust, okay, before you start coding with Solana and all of that. You need to understand the language. So let's dive in. So the first step we want to proceed with this is actually installing Rust, and you need to have what's it called, VS Code installed, because we need some certain extension that will help us to be more performant as we go. So you just look for Rust installation, go to that page, I think it's in Rust, and then you go to to/install. Okay, so here we go. The recommended approach, of course, is to just copy this line of code and run it on your Unix like OS, okay, which Mac OS falls in there, Linux falls in there. Okay, there's another method for Windows. I'm not going to go into all that right now. So just find your appropriate installation guide and have it installed. For me, I've already installed this by just running this piece of code on my terminal. I'm going to open my terminal now. Let's see, terminal. Okay, so you just copy it and run it here. You paste here and run. But I'm not going to execute this because I have already, I've already installed this on my computer. So once you have that installed, you make sure you open another terminal and check if everything was installed. So if I do say Rust C, okay, dash version, okay, you can see that. Let me enlarge this. You can see I have Rust. This is the version of Rust that I have, and this Rust, the benefit of installing this way, it actually installs Cargo for you, and Cargo is the version of NPM for the Rust ecosystem. So it's not like NPM, but for the Rust ecosystem. So if I do Cargo dash version, you can see I have Cargo right here. So these are some of the things that you need to have understanding. You can do Cargo, dash help, and you can see its usage. That is, this command helps you to create a new Rust application. So I'm going to cd into my space ls. I will say Cargo new, and you specify the name of the folder or the project. I'm going to say new Rust YT, and it's just going to create a new application for you. It's just very fast. That is one of the things I like about Rust. So fast, no craziness about it. So if I do ls, you can see that I have that Rust project here. I can then do code just code this particular one. So you have the project open on VS Code. That's fantastic. And these are the various things you need to know about this project. This is just Cargo and package.json version, you understand, which kind of elaborate the information about Rust right there. So, and this is like package.json .json.log, that log version of it, and this is where your project is being compiled to, okay, and this is where all the source are. This is the main file. So right here, if you want to check for errors, so okay, if you want to build this application so that it can then compile into this folder, you run Cargo build, and when you do that, it just compiles this and it's ready to be run. So I can then do Cargo run, and when I run that, you can see that hello world right there. Nothing crazy at all. Okay, so, and in case you're making any error, like for example here, I can run Cargo check to see if every syntax is correct, and if it's not correct, it's going to show up here. Okay, so we have, as you can see, tells you the line of code and what is going on here. It's trying to say that unterminated double quote string. So you see that I have not resolve that. So when I save that and do that, if I will check again, you can see that everything is all good. Okay, so these are the basic things you need to know. And again, if you have any dependency, like if you want to install a certain package, this is where it's going to be listed. Okay, so under this dependency clause here. Now there are some certain extension that we need for our VS Code. I'm going to click on this extension. We search for Rust. Okay, this is extensions, extension pack. I'm looking for that Rust extension pack. Probably, okay, this one, this is so this is actually the one I was using. Okay, this is extension pack. I think probably they have a new one. This is also Rust extension pack. It has about 3 extensions, which is Rust Analyzer, create, and some of these. Meanwhile, this kind of have Rust language analyzer, create, and this. So you should install this. I think this has quite a lot of users, and this also has a lot of users as well. So I installed this, and this is one I've been using. This is the one I've been using. You can also try the other one as well. So, but what this helps you to do is to, link to your code, helps you to code better, okay, and to make sure that you are not coding blindly, okay. So that is what these things they help you to do, and that is the most important things that I wanted you to get started with this. We're good here, okay. So in the next part of this video, I will start showing you different things that you need to know about Rust. We just dive in straight, no too much explanation. You just see these things at real time. And by the way, it will be very good. This video is not optimized for someone that doesn't know how to code. This video is for people that know programming already, so that as you're learning this, it's basically you transitioning. You understand? This is a transitional video. It's not a video to bring people from zero knowledge of programming. It's to help you already should have programming knowledge, and then you have interests for blockchain, because everything in this project, in this course, is optimized for the blockchain space. So how the examples that I give, everything is all designed to help you as a blockchain developer. It's all speaking blockchain and smart contract statements. There is no random example. All the examples are intentionally crafted that way to bring you into the space where it will be easy for you to apply the knowledge of this Rust in your developments, in various blockchain network as you choose. All right, so with that said, let's see you in the next part of this video. So in Rust, everything has to compile into this main function. So, and the way I'm structuring this, I would want to make everything be on their own personal files, and I will just drop it here. So it's the concept of import and export, okay? So I want to show you how that is done. Like, I'm going to come here, for example, I'll create a new file. I'll call this file module1.rs. Okay, so in this module 1, I want to bring this particular line of code here, okay, instead of it being here. So I'm going to bring it here, and I will put it inside a function. Okay, later on you will see how we'll discuss about function, but for now just know that this is a test function, or let me call it demo function. Okay, so I'm going to paste that here. Okay, so this is you see how, because of this analyzer, it helps me to, all the extensions that I've installed, they are working under the hood to ensure that, I get things done properly. For example, if I do this, you can see this red sign. It's because of that Rust analyzer, you can see right here, I don't know if you can see this, but this Rust analyzer is watching under the hood to make sure that I'm coding correctly. So now I don't want to use this method. Instead, I want to import it, and to import it, you import it as a module. This is a keyword for module. Then you specify the name of the module. For example, this module 1, and in this module 1, I can then, say this module 1. Then this is called namespacing. It's more like a dot, accessing the content of a class or something. But this is me trying to, access a method within that file. So the modular system of Rust is just awesome. I like it. It's just clean, straightforward, and efficient. So this is, and make sure, please, every line of code in Rust ends with a semicolon. All right. Semicolon is very important since it's a statically typed language, so you need to understand that. So at this point, I basically have done the same thing. I could run this check process. You can see there is no error here, and then I can do run. I can build first, before running, but it's still the same thing at the end of the day, because each time that this code is run, it has to rebuild, especially if you have a fresh update then to recompile that. You can see it's finished, and here we go. So that is just, me showing you the concept of modular structure. Now I'm going to rename this file. This is how the file should be. Sorry. Oops. Okay. Rename this. Let me bring it out here. That was an error. I'm gonna remove this. So this is the name of this file. Call it. This is module 1. I want to discuss about data types. In this particular module, I want to show you about data types in Rust, how it is different. And if you're already coding with smart contract, this should be just at home, because most of the smart contract language that uses these concepts, that is very, they use this low-level language that can easily compile to, WebAssembly. You understand that? And so you find out some of the examples are just similar to what you may already have worked on in Solidity. So I'm going to remove all this for now. All right, or I'm going to comment this out. The reason why this is looking, a little bit dark is because, we haven't imported this yet. So I'm going to do that now. We come here, instead of this, I'll say module. This module, this is the name of the module. I'll just do this, save that. Okay, make sure everything is running. Yep. See that it compiled because there was a new change in the code. So I'll come here. You can see how this is lighted up now. It's no longer dark. So let's discuss about primitive data types. So it's kind of raining outside now, so you may hear a little bit of some noise, but we'll have to continue. So let's create a function. I'll name it primitive types. Data types. Okay, this pub in front of it is a function because it's the name of a function. It kind of makes it visible outside of the file. Okay, if you don't put that, it's going to be private by default. Okay, so you can see this demo is public because it's a public function, so yeah, so that's why we put pub in front of it. I just like the name, way it's actually named function, pub function, and then this. So don't worry about the function. I'm going to come to explain it a lot deeper in module 3 of this project. So let's jump in. The reason why I'm putting it like this is because we want to, bring order and structure to it, so it will be a lot easier. So the first example I want to give you is, this is a data type called, let's call this token supply. Token supply. Token supply is it's going to be of a data type of unsigned integer 1 to 8. and it's going to be large. This is the highest in TypeScript, although in Solidity we kind of have like 256, which is really more higher than this, a double of this. So what is this about? We want to put a very large number. If you're going to be holding a large number, you have to make sure that the size of the unsigned integer or whatever data type you're using is actually large. So this is it. This here is exactly this separation with underscore doesn't really make any difference. It's just for human readability sake. The compiler sees it exactly as the same. Okay. So if I want to, this is unsigned integer. We also have an unsigned integer. There is U8, U16, U32, U64. These are various sizes of unsigned integer. Then we'll have what is called block number. Signed integer. So let's say let. Please be aware that you use let to create variables in Rust, which is pretty cool because it's kind of the same thing that we do in JavaScript. We use let as well. So let block number is equal to let's say minus 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay. This kind of find a way of suggesting which size you should use by default. Now, this is enough to host this. Okay, but you can also bump it up to 64. This is the size of it. The reason why this is very much emphasized in Rust is because Rust is memory management application programming language. It has to be memory efficient. So if you're not going to need, if this is not going to exceed more than this number or this size, if it's a large number, you use a large size. If it's a small number, use a small size. How you print information on Rust is by just saying something like print line. It's more like console.log, in JavaScript. So I would say token supply, and which is to 8 is, then you supply this. This is an interpolation symbol. You use this along with a double quoted string to interpolate or put in a variable inside a string. So in this case, what we want to do is to supply this token supply. We now replace this. Okay. We also want to do for block number, and this is going to be on signed integer, which is 64, and we'll call this block number here. Now I want to let you know that the difference between I and you is it's only based on integers. Integers can either be signed or unsigned. You can see that this sign means that it can be negative or positive, but unsigned means that it can only be positive, ranging from 0 to infinite or whatever largest number there is possible. Okay, so and then unsigned is it can go to each end, negative infinity or positive infinity, so that is the difference between signed and unsigned, in case you don't already know that. Now I'm going to execute this function here, by calling it here. So I'm going to remove this. It doesn't need to be public if we are not intending on calling it right here. So I'm going to say demo. So let's execute that. Cargo run, it's compiled, and you can see it has printed out those two information. So let's go a little bit faster and a little bit more, So I'm going to just bring in some variables real quick. This here is called token price. This is floating point. That is numbers with decimal places. Okay, and it can be negative or it can be positive. We don't have I don't think we have we don't have unsigned and signed float. It's just float. Okay, so this is size and this is what it is. Okay, and I also want to specify, this one, that's float example. Okay, these are just two float examples. You see the way I'm using blockchain terminology to specify, to bring this example to life, and you can see where where this use case can be very agreeable. Like you can, this is good for transaction fee because transaction fees are often very small. So you can see where their use cases appear, and we can always print that out as well. So I'm going to print out the token price, the token price and the transaction fee. Okay, so this is quite interesting in case you are doing something like what would I call it, writing a smart contract or so. So I'm going to do something simple here. Before here, I'm going to print something. So print line. I will create a new line here. So this is to create a new line to bring in some separation. Okay, so if I do this now, you can see the separation right here. I could also bring it in, to this place to try and separate each one of those functions so that they will not be all cluttered, together. So I'm going to run that again. You can see, so these are the token information, and let's proceed further. Let's talk about Boolean data type. Okay, for Boolean data type, it's a true or false. Like you can see this example here is transaction valid, and the data type is Boolean, either true or false. And you can just print it out here, no issue. Okay, and we also have a data type called character, in Rust, and a character is symbolized with char. You can see this symbol. This is almost similar to how TypeScript does its stuff. Okay, and you can see that character is only a single character. You can't have more than, you can't have on that thing here, otherwise produce an error. A character can only be one, one item, one alphabet, or one content in a single quote. Okay, it has to be single quote, not double quote. If I say double quote here, it will produce an error. Okay, character symbolized with a single quote. Okay, so that's it, and let's run that and see. So we have character, and all that. And lastly, let's talk about string. Okay, so for string, let's say we have something like this is a string. Say let wallet address. You can see for character, this is data type for character, for Boolean, for float, unsigned and signed integer. Now, but for string is actually str. Okay, but we use this ampersand before it to specify for string. Okay, string reference basically, and here you can supply a wallet address or whatsoever that you want. So this is immutable. This is what is called immutable. Okay, string. There are two kinds of strings basically. So this here is called a string slice, a slice of string. Okay, and it in Rust there's a difference with this. Okay, there's a difference between a slice of string and an own string. I'm going to show you the difference between that. So for example, this is for a slice string, and let's also have another one called contract name. Is, you can say string. Okay, you see you have to specify like that name, and is of a type of, so it's of a type of string, and you can access this. This is how you make an own string. Ownership will be discussed very soon. In Rust, there is a certain concept called ownership and borrowing. It's a full subject on its own, and it's very important that you understand ownership and borrowing in Rust, because The entire programming language is based upon these concepts, and you cannot bypass it. It's not just there in other programming languages, at least the ones that I've checked, but in Rust, it's just, like, it's like the blood of Rust programming, ownership and borrowing. So that is the primary reason why we have this string slice and then this own string. Okay, so those two are different. Okay, so remember we're going to be talking about it. So let's print out this. These are the primitive data types, okay, that you're going to be needing. I think I could put something like, decentralized exchange. So every example here has to correlate with blockchain, so to bring that concept really close to you. Okay, so at this point I could just run this to check it all out. So these are examples for primitive data type in Rust. Okay, so we have some operations. Let's do some operations here, arithmetic operations. So for these here, these are all the things you're going to need, okay? All these data type, majorly, these are what you're going to be using in creating variables and all of that throughout this application development process. You're going to be making use of all these various data types, when creating variables. Okay, so we have another one called arithmetic operation. So this is just plus, minus, and all of those things. So I'm going to create two variables here. One is going to be called account balance, which is an signed integer. Okay, a signed integer, and we're going to keep it, for now. If it's in the real world, like in the blockchain space, you may not want to use, signed integer. You may want to use unsigned integer, chiefly for the, fact that you don't want an account to be less than 0. Okay. So, but for this example, let's just flow with this. All right. So this is the transaction amount that we're using in transaction. Okay. So I want to do some manipulation here. So let me show you the various operations that we have. So these are the various operations. I'm going to print line, the account balance, and I'm just going to print out the account balance and also the transaction amount. This is the first line of code. Then the second line is just subtraction. So I'm removing that account balance from this. You can see that the new balance is just whatever the value that comes as a result of me subtracting, a transaction amount from account balance. The same with multiplication. The same with division, and this here. Okay, there's also plus in case you don't know, but if you want to add it together. Okay, so this is this one here is called remainder. Okay, it's modulus. Okay, modulus. What happens is when this is divided, whatever is the remainder, that is what this modulus-based system. I'm sure you already know all these things. These are concepts that are very predominant in all programming language. Every programming language does have this, enablement. So you save that. So those are arithmetic operations. Let's just see their results. So I'm gonna do this. So let's see the result. I'm going to run that, compile, and you can see here we have the account balance is 1,000 and the transaction fee is 250. You can see the subtraction. You can see the multiplication. Okay, so if I multiply the transaction amount, this is what I get. This is the division. Okay, if I divide it by 4, I get this, and if I check for the remainder, if I divide this by 3, it's going to be remaining 1. So it's going to be 300 remainder 100 basically. All right, so those are some things that you need to understand about mathematical operations in Rust programming. Close this. So now next let's look into, we're not done here though. There's some other things that we need to check out. So another operation would be working with very low gas fees. Okay, so for example, operation that has to do with gas fees. So this is a very small number right here, and the gas that is used, is this. Okay, so those two numbers, I want to just print out their value. So this is how you print out their values. Okay, of course, like we've always done. Okay, so this will be interpolated inside this square bracket, and this will be interpolated into the square bracket. Okay, and what if I multiply the both of them? Okay, so if I say total gas fee, let me see this, print 9, total gas fee. Okay, so the total gas fee, I want to say, should be the multiplication of this gas price by the gas used. Okay, so if I run this operation, this is what I get. Okay, I can format this. I can go a step further to format this. Let me show you this formatting. Okay, let's run that again. So basically, you're saying we should have 8 decimal places, okay, by adding this piece of code here. We're formatting it. This is a format symbol, okay, and we're saying that you should have 8 decimal places after the value. So that is for formatting string, operations in arithmetic. That is in Rust, okay. So I think let's jump into the next part of this. So we want to look at logical. Want to check logical. I could just make this, kind of uniform. Logical operations, okay. Logical operation is basically things that result in true or false, okay. Operations that result in true or false. So, like I have 2 variables here. You have taken and is true by default, and has sufficient balance is false by default. So I want to just print out their values first. Okay, you can see it's taken, comma, has sufficient balance. So I'm printing out their both values, and I want to check, can, if I say, sorry, duplicate this. I want to say, can perform staking? Can I perform staking? So how do you get that? I want to say, is staking, is it true, and has sufficient balance, is it also true? So if the person is taking and has a sufficient balance, then this whole operation should become true. So the both conditions must pass before it results in true. This is what is called an AND logical operation. And meanwhile, this one will be called can either perform withdrawal. Let's use that statement. So you can either perform staking or withdrawal, okay, if any one of them is true. Okay, if just one is true, then you'll be able to perform staking or withdrawal. So and the symbol for that is this double pipe here, and that will help us to it will result to true or false, so. And then lastly, we have a negating symbol. This is for another logical operation. So negating staking status. So if it is taken is true before, right? So we're just toggling it, inversing it. So by putting it this ampersand, this exclamation mark in front of in the front of is taken, and then it turns the value being default to be true, then it will not become false. So that is what those two operations do. So I'm going to do this now, say logical operations. So, and I run that, you can see it's taking is false, it's taking is true, and has sufficient balance is false. You can see it can perform staking is false, and can either perform staking or withdrawal to be true because one of them was true. Okay, and lastly negating staking status, which by default was true but now it is false here. So those are just some logical operations and how they are operated in Rust. So we have other stuff. So this one here is a public function. Okay, so this is variable shadowing and conversion. Variable shadowing and conversion. So let's say we have, an account balance of this. So this is the initial account balance. So to shadow this variable, is basically like redeclaring that specific variable, which in let's say which is permissible in Rust. So what I mean by that is I can still come here and say let, basically what I'm doing is I'm rewriting this variable. So I'll say account balance, I'm redeclaring this variable plus 100. So this basically updates. This is how I do an update of this variable scope here, okay, by just redeclaring this variable. Okay, this is one of the advantage of using this Rust analyzer, this Rust extension pack, because I could double click on this and it will insert the data type for me here without having to do that by myself. So I then could have the updated account balance. So let's have that here, updated. If I save that and run this, so you see that it's complaining that this particular function is not being used, so I need to bring it up here. So now I have it there, so I can run that. So this was the initial balance and this is the updated balance. So listen again, this concept is called variable shadowing. Variable shadowing, that is what it's called. So let's perform some variable conversion. So for example, this right here is a floating number, okay, a floating point number, like you can see. So what if I want to make sure that this number becomes an integer? I say, for example, I want this to be an unsigned integer. Say gas fee in integer should become this gas fee, this one here, and then I'll say as I32. So basically I'm converting it to a floating, to an integer, and we can actually see this work in action here by running this code and see. So you can see here that the initial value gas fee in float is this 0.0025, and then when you convert this to integer, it becomes 0. What if I change this to, what if this is 4, before 4.0 something, let's convert that, and what does it remain? So it gives us 4. So it gives us the whole number. What if I have 0.5 here? Does it actually approximate it? No, you can see it doesn't. Okay, what if I increase it to, let's say, 8? Does it approximate it? No, it doesn't. It only gives you the whole number, or the first non-decimal number. Okay, so that is what it does. All right, so there we go. That is what is called variable conversion. What about converting a string, an integer into a string? So let's try that with this variable called block height, and this is the number for block height. All these terms are blockchain terminologies, okay, which is pretty cool, and being that this course is here to help bridge that gap, okay, by actually using blockchain terminology. So let's say here this is a variable called block height in string, and how you can convert this block height to string, it's not exactly like this, but you can use block height dot, it's a to string. You understand? There is that functionality that enables you to convert this to a string, and at this point you can then check on their values. So if I check this and run that, you can see that this is integer, and now this is string. Okay, so that is how you do value conversion, okay, in Rust. Variable conversion. All right, what else do we need to check for these basic things? Mutability is ability to change or update information, okay, about a variable's information. And there's a lot of laws that regards mutating the value of a state in Rust, and let's just take them one after the other. So for example, this here is classified as an immutable variable. So that means you can just come and say token supply now is equal to 2. Okay, you can see that it gives you error, okay, because you don't override it that way. That is very funny, but this we do it all the time in blockchain languages such as Python and JavaScript, but it doesn't work like that in Rust, because Rust statically type, and this has to be declared whether you want this variable to be a mutable variable or an immutable variable. Okay, so you can come and do that. You can't even do this either, so this is not going to work out either, so you have to comment this out. Okay, if you keep it here, you save that and you check, do cargo check, is also going to complain cannot assign twice to immutable variable. Okay, so I'm going to comment that out now. If you come here and let's check out a mutable variable. How you create a mutable variable is, let me show you here. So say let user balance, this is still immutable, but if I want to make this, if I want to be able to change the content of this variable, I have to say mute, short form for mutation, so it will be able to allow modification. All right, so now let's check the balance of this mutable mutable user balance before a transaction happens. You can see, you will be able to see the balance, and then we will then update this user balance by subtracting let's say 50 from it. So if I subtract 50 from it, and I want to, this after transaction, the user balance. So this, let's check it out here. Let's say we'll comment out this so that it will not be running, but now it's going to produce a lot of warnings to us, so let's just keep it like this. So we have mutability. Let's check it out. This is cargo check, please. Let's do cargo run. Okay, you can see that. So the balance of the user before was 500, but after the subtraction. So you can see that this is permitted, okay? So these are some, some things that you need to understand about mutable and immutable and mutable variables. Immutable and mutable variables, it's very much applied to all the variable data types, okay? Such as string, float, and all that. So you should bear that in mind. So we also have, lastly here, we have a thing called tuple destructuring. There is a concept of destructuring in JavaScript, but let's see how it goes with in Rust. So this is called tuple destructuring. What does it mean? So to create a tuple is, let's say, transaction info. We have this. So this variable called transaction info, it will contain this thing called a tuple, and this tuple has, this is almost like an object. You understand? It's almost like an object in JavaScript, okay? And so a tuple has a couple of different, I could add different data types inside of it. So it's a data structure, okay? It's a data structure in Rust. So say transfer, you can see as I include anything I include here, it's just specifying it for me. This is because of the Rust analyzer extension that I do have. So that will be a string. I also include this. That will be an unsigned integer. And lastly, this is a float. So you can see how it lists it for me. If I double click this here, you can see all of these are just applicable. So I'm gonna just let it go for now. All right, so save that. So this, so you can remove this, sorry. Okay, so this is what it defaults to, okay? You can decide to include that, or if you want to modify that. Let's say if I want this to actually be 64, sorry, then I can modify this. Otherwise it will use the default variables, okay? That is what, these are the default ones, okay? So at this point, let us destructure the tuple. To destructure a tuple, remember this in JavaScript, we now have something like, let's say if it was an object, and this here transaction info is an object, I can then select the information about it. For example, I'll name the first tx something. I could pick up this specific data inside of it, but in Rust you have to use this. So this is how we do it. So the first item in this tuple is the transaction type. So I'll say tx type. Okay, so the second one is tx amount. So this amount, and then the third one is tx, tx fee. So in reality, this is how you should, this basically is telling you the data type that this type is. This is a string, just like it is here. This is a number, and this is a float. So these are just some basic things you should understand about Rust. So now we have this as various variables. I can then, I can then log them out, by printing them out here. So you can see, the transaction type, amount, and fee by just putting this value. I can also access this value by just using that dot notation. So if I say something like this, let me duplicate this line. Okay, so for example, if I'm not going to use this destructuring method, then I can use this, transaction. Okay, if I say transaction to get the first element of that, the first element of this tuple, I'll say .0. So that will give me access to this transfer. Is if I say dot 1 and dot 2. These are various content of this tuple here. Now let's log this out and see how it is. So I'm logging that out. Watch it now. So you can see first one, you can see that this destructuring method works just fine. I actually do like the destructuring method because it gives more unique specification of exactly what you are logging out. The one of numbers are just a little bit difficult to manage, in the long run. Okay, so this is basically module 1 completed. These are the various data types, that you will be making use of, and mathematical operations. There are other mathematical operations, other kind of operations, such as the bitwise operation. I intentionally removed that because that is a little bit complicated, and in reality, we don't often use that kind of operation. Okay, so these are the various things you need to know about data types, and these are the various examples. So when you're jumping into Rust, you need to understand how to code this way. All right, so in the next example, I'm going to show you control flows. Okay, control flows are like if statement, loop statements, and so on. All right, so I'll see you in the next part of this video. All right, so we just finished the module 1, so let's jump into the module 2 right now. And let's come here. I'm going to create another folder, another file. Now in this module, we want to discuss about, I want to show you how to deal with control flows. Okay, so that will be if else statements, the loops, structures, and all that. Okay, so the name of this is going to be module 2, control flows examples. Come on, I thought I removed. Okay, I didn't come here, I brought it back. Okay, so here we are. Now I'm going to just create a function, public function, call it demo, and make that exportable. So at this point, I need to comment that one out. So you say module 2, control flows, and let's do this, save that. Okay. I'm supposed to give it a parenthesis right there. All right, so let's start with a basic if else statement. Okay, so I'm going to come in the module 3 and discuss what function is and how you create it. Okay, I'm just wrapping everything in a function because I want order, and the flow of these teachings should be very easy for everyone to understand. So I want to show you the basics of if else statements. So like we are already used to how you declare a variable in Rust is by using the let keyword. Okay, so let's say we have a variable called transaction amount, and it's like 100. This is the amount that somebody wants to send to another, to a recipient. Okay, so you want to check if this transaction amount is greater than 0. Okay, because you don't want to send an empty transaction. If that is so, you want to, for this case, if you're writing a risk smart contract, then you can perform some operation. For this case, we just want to print out, a statement saying transaction is valid. So if this transaction is greater than 0, okay, to be valid. But else, we have else, else if you want to have multiple, conditions. So else if this transaction amount is less than 0. Okay, Then you want to print out another warning saying invalid, invalid transaction, and you want to say negative amount. So you can send negative amount. Okay, this is very important. And then you have an else statement, okay, where you can just print out transaction amount is 0. You see no transfer, no transfer. So the funny thing or the cool thing here is you can just remove this particular block and just have only if statement, this if else statement, or you can also have like 3 condition, checking for 3 condition, okay, checking for 2 conditions and giving 3 response. Okay, this is like the third condition. All right, so this is how you basically check an if statement, and of course you can run that here to check state. So you see cargo run, and when you run that, you see transaction is valid. What if I put -1 here? Okay, let's see transaction, invalid transaction, negative number. What if I want to transfer 0 instead? You run that, you can see that transaction is 0. I think I'm going to bump this up again. It doesn't help either, it just stays down there. So maybe when I'm editing, I'm going to make sure I erase that part so everyone can see. I could also do something here. Let me see what I can do here. I can print out some new lines. Okay, if I can print out that new line when I run this again. Okay, at this point it will be showing this here, so this is important. I can even bump it up a little bit. Okay, so that when I run this, yeah, the result will be clearly up here and not down here. All right, so back to this place, control flows. Now we want to also check, there is a different way of you checking a condition, all right, of a variable or a value before you perform certain operation. It's called matching. Okay, so let's try some matching examples. So let's say we have another function called match example here. Now for this match example, we're going to pass in a parameter. Now a parameter is something that is something that you use in feeding a function, is how you pass value inside a function, okay, and having a function to be self-contained, without the function having access to the variables that surrounds it. So you want to pass in an argument there, through this parameter that we have here. Okay, so we say day is going to be U8. Why it's U8? Because we know that days are we only have 7 days, so it's not more than 8. So it's just a perfect example there. So if you count from 0 to 7, that will be 8. So long as it's within that range, you're fine. So now, how do we check for condition with match statement? You say, for example, block day will be like various activities that should be performed in the blockchain. Like on a Monday, they do this. On a Tuesday, this activity is performed on the blockchain. On a Wednesday down to Sunday. So there are various operations. Some are background tasks that runs on these various days. So you can use this example to do something like that in the real world. So you want to match. Use this keyword called match to check, this day that we're receiving as a parameter. Okay, so if this day matches any one of these conditions, then it's going to resolve. So the first condition is if day is 1, then you use this fatter arrow arrow keyword, this arrow expression. I mean, we literally use it in JavaScript, in line with the fat arrow function. So this is an arrow. Okay, and you want to say something like, if it is day 1, we are expecting, if day is equal to 1, we're expecting that, what will happen this day is block production on Monday. Okay, we're expecting that will be a Monday. Then I'm going to just paste these are ones. So we have, if it is Tuesday, which is second, you have to separate all the condition you're checking. So instead of doing all this, I can just do this. This is a lot faster. Like, I could use it to check a lot of condition at once. This is what some language we say switch statement or case, checking for a case, you understand? So but this, I like the way it is done in Rust, because it just pretty straightforward with the syntax is just pretty fantastic to me, and you can actually get the result and store it in this variable, at the end of the day, which one it is, and then you just prompt it. So, but in this match statement, there is also a way of you checking if there is any other thing that doesn't match these 7 operations. Okay, then it will be, let's say something like invalid block day. Okay, so but you don't check it for a 7th condition, but you use an underscore. This underscore is used in specifying that if there is any other condition that is not captured by these ones, then this should be what must run. Okay, so with this example, then you can then print out the block day. So you can say print out, print line, say blockchain activity, and we interpolate block day. So this is cool. Now we can test that out and see how it goes. I test it. Let's copy that, come here and say, if I put 0, make sure I end this with semicolon. But if it's like the last item on that line, it may not have, or the only item on that line, it may not complain. So I'm going to put 0 and see how it goes. So let's run that. We can just close this, end that for now. So you have invalid block day. Okay, and what if I even try something like 10? Just to say invalid block day. Okay, something like 100. So those doesn't work. So let's try something like 7 and see. Yeah, no activity on Sunday. What about 5th? Network upgrade on Friday. That is pretty fantastic. So you have that match, case matching, formula, an alternative to an if-else statement. This will be very useful when you have so many conditions that you have to check. But if you just have a 1 to 3 conditions that you just want to check, I think this will be like the most effective way of doing it. Like for 2 conditions, if you ask me. But if it is more than 2 conditions and it's 3 and above, then this will be very, useful. All right. So now that we have conditional statement met, let's check on while loops. Okay. So let's look at a while loop example. We have while loop here, and While loops, of course, you know how it goes. It's used to perform recursive actions, things that you want to do over and over again. So let's create a variable called say let pending transactions equal to 0. So this would be very cool if you're trying to process a lot of transactions at a go. But the nature of this while loop is that this variable is more like an index that we need to continually upgrade. So but before then, we have to come here and say use this while this pending transaction is less than 5. Okay, we want to do this, carry out this action. We want to say print I want to say print in, and we just want to print that transaction index. So I want to say processing transaction number this. If it's in the real world or contract that you're writing, you can then perform a couple of operations that you want to achieve here. Okay, so it's going to perform the first operation and at the end it's going to print what's it called? At the end, you're going to say all transaction processed. Now, the problem with this while loop is if you don't have something that can terminate this condition, it's going to be running forever, and you don't want that to be so. So that's why you can, for every time each transaction is processed, each pending transaction is processed, you want to increase the index of this. You want to bump it to the next transaction so that it can be performed as well. Okay, so but the reason why this is giving us error because this variable is an immutable variable. You can see here saying cannot mutate immutable variable. So we have to make sure that it will have that keyword here called mut to specify that you're going to be updating the content of this variable as it runs on the go. So let's test it out. Okay, so I have this and is that. Let's see how it goes. Okay, you can see that it processed first, second, third to the 5th transaction, and all of them are processed. So that's how you run while loop in Rust. Okay, so what about a for loop? Let's look at a for loop. A for loop is similar to a while loop, but a for loop is much more controlled. You understand? In while loop, you have to be the one to specify all these things, manage the index counting and all of that, manually, and if you make mistakes, it's going to fail. But a for loop, it is encapsulated in the formula or the syntax of the for loop structure itself, which is pretty cool, which makes the job a lot easier. So let's say that we have a variable called staking reward. This staking reward is an array, basically. I'm going to be discussing with you on data structure, okay, on the 4th module of this course. I will show you data structure, different kinds of data types, data structures, such as arrays and hash map and tuples and all of that. You're going to see it in action. So now just think of this as a regular array. You do have, let me make sure that I was taking reward. Regular arrays that you do have on your various programming languages. So let's say 10, we have 20, we have 30, we have 40, we have 50. So we have these various numbers. So these are various staking rewards, okay? Let's say these are various staking rewards in a protocol, in a blockchain. And then, so this are supposed to be going to validators. Okay, this taking reward supposed to go to validators, because let's say something like in a proof of stake blockchain or consensus model, we have validators, and then for each successful mining and validation of transaction that these validators perform, they get some reward. Okay, let's say that's a list of the reward, and then you have a for loop. Okay, so you say for, you say this reward, we call it reward, as a single item in this list of array, in this taking reward. Now we are converting it into an iter. An iter is an iterator. Okay, it makes the array, iteratable. You understand that? So that's why we're having this iter here. So each item in that array is going to be, walk through. So each validator, we can have print line, say validator reward, you do this, you say this reward. Okay, so it's going to print out all of that reward. You see, this is really cool and straightforward. I have no reason to specify, like, I don't need to specify this this counter, and I don't need to be increasing it here. Everything is just managed for me by the for loop. I like the for loop the way it is designed, because it just basically manages that whole thing for me without having to specify it. I just need to have an iteratable array, with content, and each one of those content will just be taken care, will be processed until it's finished. So all of that is managed by itself. So this is cool. So that is one, that is a fantastic way of doing it. But there is another fantastic thing that I do see about this. Rust as well. The last programming language that I saw this abilities in Ruby programming language, but I think Python may have it as well. But what happens is that you can iterate through a range of numbers. So if I say block, for each block then I have a range of number that I want to iterate. So I want to say iterate from 1 to 5. Okay, and for each time I want to print produced block number, when I say block. So something simple like this will be used for it will be used to simulate the production of range of block numbers, on the blockchain. So something similar to that. So let's test it out. So I'm gonna come here, I'm saying this, and let's run this. Okay, you can see this is each one of those validator reward. This is the first for loop, and then this is the second for loop that is based on a range of number. Okay, also have infinite loop example. Okay, so a loop structure that is infinite, so this could be useful as well, in various blockchain development experience. For example, you want a structure that can be used to check the state of a contract. You understand? So if you want to be checking the state of a contract, and you want that structure, that loop to be up and running, there's a certain keyword called loop. So let's check it out. Okay, we have a variable here called attempt. Okay, this is going to be updated, that's why we're having this mute in front of it. And then you have this keyword called loop. Okay, now this is how you write an infinite loop in Rust. You want to say print line, say checking blockchain state. Okay, put the triple dot and say attempt, and then you see this attempt here +1. Okay, so this is the first attempt, and then you immediately bump this by 1 because it was 0 before, so increase it by 1, and you do an if statement. So say if attempt is equivalent to 3. This 3 is like you want to make sure that it's at the maximum 3 attempts before it quits. You understand? Because if you don't have like a breaker scenario, this is going to run forever, and it's going to be highly, it will be computing intensive. Okay, so, and that is one of the things you don't want to do on the blockchain application. So at this point, you want to say, let's say breaking the loop after 3 attempts. Okay, so you can just do that full stop and remove that, and you use this keyword called break. That will just shut down this loop from continuing. So this is how you write an infinite loop, other than the first method that I showed you with while loop. But why you want to use this method is because the while loop method, if it fails, if you don't put that in that caution in place, it's going to really destroy your application. It's going to just run forever, and you don't want that. But this would definitely have you this will just work just fine. You understand? Because it will require that you have this break statement. This is very important. Okay, so let's comment out this and use infinite loop to check. So it attempted the 3 blockchain state, manipulation or clearance, whatever procedures are going on there, for 3 times. So that is an example of how you can use infinite loop. Okay, so we also have matching patterns. So another method as well. So want to match some patterns. Okay, so matching pattern is more like a regular expression pattern, which you use to detect certain patterns. You want to match certain things and then, check a certain activity. So we've already done this before, where we have those match statement here, but let's expand on it. It's not only about just specifying numbers in this way. You can also do some more interesting matching, checks. You understand? So for example, we want to match, if we have a number here, and let's call it I32. Okay, so this is the data type, and you want to use this match keyword and say want to check for this number wherever we find. If this number is equal to 1, if the number is equal to 1, we want this. Okay, want to print this line, say executing token transfer. So, but if it is actually 2 or 3 or 4, okay, or 4 or 5, okay, or 7, okay, in this case we want to print another statement. We want to say executing a prime validator operation. Okay, and we also want to use, you can also match using range. Okay, so we want to say if it falls into this category of 10 down to or equal to 19, okay, then it should perform this operation, say performing governance action between block 10 and 19. Okay, so this is just sweet. You can see different way of performing matching, which is really cool. But then if there is no any other option, you can always terminate with this by saying unrecognized operation. Unrecognized operation. Okay, so this is a pretty fantastic matching pattern. So I've shown you the regular matching patterns. You can match against string. It's not only numbers that you can match against. You can match against string. You can match against Boolean data, any kind of data type that you want. You can match against it. So, but in this number one, we've shown you different ways of matching. This is pretty cool in my experience. If you ask me. Okay, so I'm going to try this now. Comment this out. Okay, so I'm saying, let's say try something like matching pattern. Example of number 5 here. Let's try that and see. When you run that, see it's unrecognized operation because 5 is not an option here. So what about for let's say 3? 3, what do we get in 3? Is executing a prime validator example. What about 13? How about that? You can see performing governance action between block 10 to 19. This is pretty cool. All right, this is a very nice control structure. You understand? We also have something called let if. Okay, I've shown you if statement, basic if statement, and I've shown you matching and even pattern matching. There is also another one called let if statement. So this let if, it checks for a condition, and also store the value of that condition in a variable. Okay, it does two things at once. Meanwhile, the first one, this one only check for the condition. Meanwhile, the one this one called let if checks for both the condition and stores the value of it in a variable. So let me show you how it goes. Let's say we have an input. Let's say this would be very useful. For example, if you're calculating grades, in a reputation system. Let's say we have bulk of users that have been faithful to your blockchain protocol, a blockchain network, and you want to check their reputation. So as they are doing their work, their reputation score is growing, and then you can use this example here to perform some validation. Some reputation grading. Okay, this is really cool. So you can have reputation score, which is an unsigned assigned integer 32, and you want to. We have this. Let me show you this if else statement. So let's say this is bulk of if else statement. Okay, if reputation is greater than 90, say high reputation. If it is lower than what's it called? If it is lower than, if it is 80 and below, like that, it's a good reputation. 70 and below, up to 70 average reputation, up to 60 is low reputation, and the rest is poor. So these values that are coming, these ones here, remember, so this has to be stored in a variable. So we want to receive the value. We don't only want to test this condition, but we also want to know if it's this condition, we want to extract this value. Okay, that is what let if statement helps us to do. And how we do that is by specifying this let statement and say reputational. Let's say reputational level. Okay, reputation level is whatsoever that comes out of these checks. You understand? So this is then stored here, and then at the end of the day, you can just print out that that statement. You know, have reputation score is this, and reputation value is this. Okay, this is cool, and let's try it. Let's try a basic example on this. Okay, so I'm gonna do this. Let me say I have like let's see 66. Let's try that as the reputation score. Let's run that. Okay, see that this reputation score is 66 and the reputation level is low. It's low because of this is the condition that matches this particular score we fed here. So what about for 78? You run that and check. You see score is 78 and the reputation level is average reputation. This is cool. So this is how you perform a let if statement in Rust. Okay, and everything here that we've been working on is designed to make you feel at home in the blockchain space, because this particular knowledge that you're getting can be applied in various blockchain networks, such as with Near Network, with ICP network, with Solana network, with Polkadot, and a lot of this thing blockchain network that uses Rust under the hood. For example, Stellar network also uses Rust. There's so many of them, and so therefore Rust is just inexhaustible in its value when it comes to the blockchain space. Okay, so and the knowledge of Rust doesn't only help you to write smart contract, but also to write the core blockchain software. You understand? So if you want to be like a core blockchain developer, you can also Rust is your go-to language as well. So now that we've done that, we also want to talk about match return example. So we want to match some certain statement, and we also want to return value. You remember, but maybe you don't know about. Just think about it like a function that returns a certain value after computation. So match can also help you to return some value after computation, not only to print a value but to return a value. Remember that in all this time we've only printed out the value of it. Even in this matching pattern, you can see that we've been printing out stuff. We haven't actually returned anything, but this time we have this example. Okay, we say match return example, and we want this could be very useful for things like network status code. Okay, so want to say status code, and this is going to be and I added 32. So this is the data that you're feeding into this function, the status code, and you want it to return a certain data type. And now the data type that we want to return is a string, a static string. So and how you do that, this is a static string. Okay, so a static string or a slice of string. So how you do that is by saying ampersand, it's a static and str. Okay, so this will return a string, but a static string. Okay, what do I mean by a static string? This is a static string, something like that. It's just a static string, just a piece of string. Okay, that's what it means. a piece of string that cannot be changed. That's what makes it static. You can't just mutate it or change it. All right. So we have match here. We have to now match some examples. To match the status code. And if we have a status code of 200, we want to return transaction successful. Okay. And okay, let's do that for about 4. So if it returns 4, we want to say transaction not found. Let's say you're querying the system, for information about a certain transaction, and you want to return the status code when it was not found. Okay, and for transaction such as, let's say, 500, so you want to return blockchain error. Okay, and this is for any other error. Say unknown status code, unknown status. Okay, so now let's check it out. So for you to utilize this, you want to come here. I'm going to comment this out. So I'm going to paste this here, and let's say I want status code of 200, which should return transaction successful. Okay, so you can just do this like this. For example, if I run this, it will seem to just run just fine, but you will not see any response. So I have to store this in a variable, call it status message. And then I can print this, that status message quickly. So when I run this, you can see transaction status successful. This is pretty cool. At this point, I comment out all of this and just run this, and just run all this at once. You can see all those things running up, all of them. We've been able to complete this module, and that is pretty fantastic. So in the next module, I'm going to be teaching you about functions and closures and everything that you need to know about functions. So that is for now. I'll see you in the next part of this tutorial. All right, welcome to module 3, and in this module 3 we want to show you how you can work with functions in Rust programming. Okay, so let's get to work. First, we need to create a file like we've always done. Come here, come to this place, create a new file. Call it module 3. And for module 3, we're talking about functions and closures. Okay, functions and closures. You will understand what function is and how, what closures are and how we use closures in Rust development. The drill, we always have a public function, and this is demo, and here we go. So this is how you create a function. The public keyword, one thing I like about Rust is that it addresses a file, or a file like a module on its own, and then whatever functions or classes, whatever that you put inside of it, they are seen like the methods associated with that file, that module, which is really cool, and it kind of made it look, made object-oriented programming really, nice and clean without needing too many, redundant word. Okay, so this is public for visibility outside of this module or file, and you use a keyword called fn for function. Unlike JavaScript, you have to write the entire keyword function. And you have demo, you understand, which is the name of the function. here is a parameter. Right now it doesn't carry any parameter, so it's an empty parameter. This is where parameters go are declared. Then whatsoever you pass in when you're using that function is called an argument. Okay, so that is just it. This function block is where you write all the code that is associated with that function. I already know that you know how a function is declared. So I'm going to save that and make sure that I'm using it here. So module 3, okay, and all right, so let's come back here. Now let's create a new function, the basics of function, just how a function is. So this is a function, and the name of the function, you understand, if it does have a parameter or not. Inside of a function, you can have another sub function, okay, which is really cool. Like, okay, for example, what I mean by that, I could create another function here and call it add, gas fee. Add gas fee. So this is an internal function. The scope of this function is limited to this basic function. So that whole idea of creating function within a function, it's really cool. So, and I like that Rust have that, scoping, I like that Rust does have that method of, just making things easy for you. Okay, so this, of course, about the principle of scope. This function cannot be accessed outside of here. If you want to prove that theory, we can call this and say, you see, it doesn't have any of those functions. You can't call that function outside of its, scope. Okay, so at this point, you want to accept something called base fee, because this should add, fees for you. Okay, base fee, want it to be I32. And gas used also I32. This is very important that you specify the size of the integer that you're using. It's really important for it. So this is a computational function. It will calculate something and return a value for you. So that's why you use this arrow function. You're specifying what kind of data type that this function should return. It should return this data type as well. So because we want to do return base fee plus gas used. Okay, and this works, but it's not necessary that you must put this return keyword. This return keyword is not necessary. The compiler treats it the same, so I'm going to remove it, which kind of shortens our code a lot more. Okay, so if it is only one code inside a function, there is no need to put a semicolon. Just leave it like that. Okay, so please pay attention to those simple details. All right, so at this point, you can say let total fee is equal to, you add the to fee, yep, and okay, so what is base fee and what is one base fee to be 100, and the gas used, let's say it's used 50, so this will calculate it and return the total fee. Okay, so the total fee would just be that. So this function simply just calculates total fee for you. Remember, we have two functions here. The exterior function is just wrapping the entire block of code here. We have an interior function that adds gas fee for us and returns the total, which is stored here, and we're just printing it out. Okay, so we can run that example here and see it in action. So you can see that it's 150 in total. This is cool. So this is the basic use of function. Functions are not that difficult because all throughout this thing, this course, I've been using it and I'll continue using it. Okay, so this is multiple return example. So in this multiple return example, I have a function inside here, and we're calling this function calculate transaction. Okay, in calculating transaction, I need x, which is I32, and let's say y to parameter I32. Okay, so what we want to return is a tuple. All right, we're returning a tuple. A tuple, I will soon discuss about tuple. Okay, in the next module, I will discuss various data type, and part of it will be a tuple. A tuple basically can be seen like an object. You understand? An object or an array as still. An array. How will I classify it? Let's say an associate array. Okay. In PHP, if you work with PHP, you understand what I mean. So say I32, I want to return I want to return three, three values. Okay, so let's calculate the transaction. We want to say, let what we call total tokens be the addition of this X and Y, and let the gas fee, the gas fee that was used, the gas fee, be this X multiplied by Y, and let the balance after the balance of the user after that transaction be this X minus Y, and then we can then return. Remember, we can simply ignore that return keyword by just specifying total tokens. This is one of the results I want to return. I want to also return gas fee, and I also want to return balance. So these are the things I want to return. Remember, I don't need to include this. Okay, and the last member of that function can be without a semicolon. It should be without a semicolon if you don't want errors. Okay, so at this point I can destructure. Okay, I can destructure that result. Destructuring in JavaScript, the concept is basically extracting the content of an array or the content of an object. So you can do destructuring with a tuple. Okay, when a tuple is returned. So for example, if I say calculate this, I want to calculate 8. I want to give x 8. I want to give y, let's say 3. Okay, so this should return a result, right? So this result that is returned should be stored in a variable. Let's say result. Okay, this is where it's supposed to be stored. You can see that it's returning 3 items. Okay, but I can decide to destructure this instead. So I'm going to pick it up, I'll pick it up as a struct, and let's end that there. So I'll pick it up as a tuple, and then say these are the tokens, and give it this name, tokens. This one is the fee, and this is the balance. Okay, so I've destructured it. Now I can use these keywords individually instead of group wise. Okay, so with that, let's print out this simple message saying tokens, gas fee, and transaction. So let's check this out. These are just basic simple function operations. So I'm going to run that. I'll go run. So you can see total tokens is 11, gas fee is 24, and balance after is 11. Okay, because it's 5, sorry, because 8 minus 3 is 5. 8 times 3 is 24, and 8 plus 3 is 11. So those are the result right there. So let's try a higher order function. Let's show you how it works. A higher order function actually is a function that accepts another function as its parameters. I see this a lot in React. React is just very cool at doing this. It's not very friendly in a lot of, I haven't done that a lot in other JavaScript frameworks, but React gets the job done really good. That's one of the reasons why I like React. But this is how it is applied in Rust. So let's say, for example, I have a function called apply fee. Okay, this is the function 1. Okay, and this is the higher order function right here, because this function is going to be used to call others, and we want to give this function, this higher order function, some specific instruction on how to handle other functions. So for example, if you have like a function, a fee calculation strategy, let's say we are calculating fee for different purposes and want to use this function to call different fee structures or different fee function that we calculate different kind of fee. This apply fee we just serve in that place of calling each one of those functions. So that is one of the use case of a higher order function. So the first parameter that we're going to need here is a function itself, f for function, and it's going to take f and gas limit. Okay, for example, gas limit, and of course it's going to be an i32 data type. So we want this function to return i32 data type as well. So after this, we want to bind this function with a trait. I'm going to be discussing about traits in the module 11 of this course, so watch out for that. There is when I will explain traits a lot better. But trait in general is a way of describing how a struct, you understand, how a struct will behave, the kinds of features, properties, and functions that a particular trait will carry and exhibit. So that is what it is in short. Okay, so for this function we are binding it to a trait. This is how this trait works. So a function, the function here, whatever function that we're passing in here, must take in an i32 data type, okay, a value of i32, and returns a value of i32 as well. Okay, that's the instruction we're giving for the function parameter. And when implementing it, this function, this f right here, should receive this gas limit. Okay, so I'm going to pass in that gas limit here. All right, so basically this is the function, this is the function, and this is the function's behavior. Okay, this is the function definition, this is the function's behavior. That's where we are binding a trait. This is the trait or characteristics of this function. This function that is going to be passed here is going to receive gas limit and return the value. It's going to receive a function and a gas limit, and then it's going to pass the gas limit into that function and returns the value for us. So basically that is what it does. All right, and then we have another function here called calculate fee. Okay, so what calculate fee does is very simple. It receives a gas limit, just like with this function here, receive a gas limit and returns what, i32, which is exactly the definition of this. So this is one function. We can have like different kind of functions that behave like this, we can call them function strategies, different function strategy for calculating different kinds of fee. Okay, and then we can then be calling this apply fee and pass in this function into them. Let me show you in total. So simply what this does is to use the gas fee and multiply it by 2. Okay, so yeah, this is what it does. So at this point you want to then say let total underscore fee equal to, call this apply fee function here. This is the higher order function. Okay, in this higher order function you want to pass in this calculate fee. Okay, and this calculate fee, and this is the function you're passing in, and you also want to pass in the value, which is 100 in this case. So this performs what will happen is this 100 will be fed into this calculate fee and it will return 200, and this apply fee will just return that 200 for us and store it here. So that is just what it does simply, and I could print out the result here. All right, so let's call this higher order function and see how it goes. Okay, so let's have it called. Okay, you can see total fee based on gas limit is 200. So this is just a simple way of me describing what a higher order function is and how it operates. Okay, so that's a good example for this module. All right, that's it for basically function. That is all you need to know about function. Functions are not so, they are just there, you understand, just a block of code that either returns or process a certain set of instructions or operations. So let's look into closure this time. So the basic example of closure. So in Rust, closures are basically functions. I think I could refer to a closure as an inline function in React, if you're writing codes in React. So an inline function, like a function that just executes on a button without needing to, you don't need to define the body of it. It's just straightforward. It just returns the value for you. So let's say we want to define a function called transfer. So I'll call it transfer function, but we want to use a closure to define this. Okay, I will put two pipe symbol here, and this is where I pass in the argument. So the argument number one will be token, and token is I32. Okay, and I also want a fee. The fee is also going to be I32. Okay, at this point this is what the closure should do. The closure should just subtract the fee from the token. Sorry, here I made a mistake. So this should also, here you have to specify the value, the kind of data type that this function should return. This here. Okay, these are the arguments, what the closure should receive. The closure is basically a function. Please don't get it confused. It's still a function. We can just call it an inline function, or a very short function, or a function that just immediately returns the value. Okay, so this is a closure, and this is the argument that it received. This is the value that it will return, and this is the body. Okay, so that is what it simply implements. It implements a function that receives two parameter. You can literally see it here, that receives two parameter and returns a value. Okay, this is what this closure is. Very straightforward. And then at this point you want to select the final balance be equal to, when you perform that transfer, then you transfer how much. Let's transfer 100, whatever token that 100 token of whatever coin that you're using, and then the fee would be like 5. Okay, so whatsoever happens by the subtraction of this, you should return 95, and that is what will be stored here. Okay, so this is just straightforward one line of code for performing this function. So it's like an inline function, but you can a closure can take up multiple lines, you understand, because you do have this. You can use this curly brace as well. Okay, but it's used normally if you want to perform a quick manipulations. Okay, what we now have to do is to simply print this out on the console. So all right, so the final balance will be after the transfer. So let's run this and see. See, the final balance is 95. That is very cool. I really like this closure thing. It's really cool, and I think you are going to also enjoy it once you have a hand of it. It may look a little bit confusing, but it's just instead of using a regular function, you're using this. So this structure, that is what a closure is. So let's talk about right now. This function only deals with variable. This closure only deals with variables that are inside of the function within the scope, but a closure also captures variables or whatsoever that is outside of its scope, and that's what we want to do. I want to call it closure capture example. So I want to capture the variables that are around the environment. So let's say, for example, we have a base gas price. Okay, this is an environment. This is a variable that is outside of a closure. Okay, and now let's calculate the total cost, okay, of that transaction or whatsoever. So we're defining a closure here. Okay, so this closure is going to receive gas used, and that is just the only variable that is using, and we just simply want to say gas used multiplied by this base gas fee price. Okay, so this is also a closure. Now this closure is accessing the value, this particular value here. So and this value is not part of the function or the closure itself. So that is how closure can capture external data. Okay, so and at this point you can just this is the function. Now this right here is a function, so we can say let total cost equal to calculate this and how much we want to pass in here. Let's say we want to pass in 5. That is the gas used. Okay, and then we can print out the result here simply. So let's run that code and see. No, it's not yet ready. I need to include it here. Come here. Okay, run that. Okay, you can see the total transaction cost is 50 gas used. So watch again that the 5 that I passed in here was multiplied by the base gas price, which is 10, which results in 50. So that is a closure and how it accesses external data. So we also want to return closure from functions. Okay, and this is going to be a little bit technical, but we can return closure like the way you return value from a function. We can also return closure from a function. So let's have a function called, this is where we'll write the implementation of this. So let's implement returning a closure from a function. So returning closure example, we want to write a function inside this particular function. Okay, so this function will be responsible for returning a closure. All right, so we'll create staking reward, and we want to call this multiplier. Multiplier is this value, and this multiplier implements this is basically a trait. Again, this is a trait. Okay, anywhere you see in this implement is actually giving a structure, a certain kind of ability. So for example, we're giving this function structure, this implement, this is function. Okay, we're giving this function that have this structure called I32, this ability, and this function must return an I32 as well. So we want to give it, we want it to have the ability to return a closure, and we need to pass in this move. So in essence, let me explain why this move is here. You see, before I even do that, let me bring in this, sorry. Let me bring in, let's define the closure. So in this closure, we need a tokens stacked, token staked, and immediately want to multiply this token staked with the multiplier. Okay, so this is cool, but the problem here is I'm going to teach you about the concept of borrowing and ownership and borrowing. Okay, it's a major aspect of Rust, because Rust is a freak when it comes to performance, security, and optimization of memory. So the concept of borrowing and ownership, it's a concept in Rust that is designed to optimize memory usage so that you will not be creating redundant things. So for example, if a variable, let me just get into it right now. Okay, I'm going to get into it later so that it will be understood. So just understand that you see this, you see how this is a closure right here, right? So this is a closure, and a closure is basically like a function in itself. So we have an exterior function, an internal function that has a closure, which is like a third function in it. So the concept of ownership and borrowership is a legit thing in Rust. This multiplier is literally owned by this create staking reward function. So passing it in here without this closure having ownership to it, it kind of violates Rust standard. So we need to find a way of giving this closure, transferring the ownership, or giving a copy of this this multiplier, the ownership, giving a copy to this closure. And how we do that is by simply just saying move. So we're moving ownership of this multiplier variable into this closure. So this is very important for it to work. Okay, as simple as that is, you're going to see how this is much more reasonable when we go deeper into describing the use and the things about ownership and borrowing. Okay, so at this point now, let's access this. So for example, let's call on this. Let's utilize this create reward. So I have a variable here, and I'm calling this create reward, create staking reward, and I'm passing in 2 as a multiplier here. So 2 is going to multiply itself with this token stake. That is for the creating a token stake. So this is the reward function now. Okay, this is a function that carries, that this function here returns a closure, and a closure in itself is a function. So I can call this reward function here and pass in 500 as the tokens, as the number of tokens that you want to stake. Okay, so I'm passing in 500 here, and I'm going to have to store this on a variable as well. So I'll call this staking reward is equal to the value that is returned from this you know, at this point now, this is basically this is a closure that is being returned. So whatever that is returned from the closure, which because of this creating reward, taking reward is actually 2. So at this point, what is going to be returned will be whatever I pass in here multiplied by 2. So this should be 1000, you know, that should be returned. So let's print that out and see the result in action. So I'm going to copy this and come here. So save that and run this. So you can see that is 1000. Okay, that's taking reward. So this is how returning a closure, you know, works in Rust. Okay, or returning another function. All right. So, and we also dived in and did a little bit of a trait definition here as well. So we should have information about that. We will discuss about traits more as we go. Lastly, we want to discuss for this closure and functions, we want to discuss about this concept of closure ownership. Closure ownership example. So the first thing I want to do, I want to define, I want to define a variable, a string that will contain a contract message. You understand? Say smart contract executed. Okay, so it should be known. Is it necessary? It should be known that this can also be defined this way by saying dot to string. Okay, so this is the same as this. Okay, so but this isn't the same. You can see that the string structure, this is a slice of a string, so you should have information about these differences. All right, so now I want to log a message. So say log message is equal to, now I'm creating a closure here, so but I'm going to transfer the ownership of that closure as well. So this is a closure that doesn't have any parameter, and I'm printing out something. This closure or this function only print out a message. I'm going to also put this move here. The reason why I'm putting this move here is to transfer ownership, because we're accessing this contract message, which is external to this move, in order for this to work just fine. So at this point, I want to say log message Okay, let's show this in action. So let's run this. See, the log message is working just fine. What about if I remove, and if we haven't done this, for example right here, if we haven't done this and we just say print line and just say something like, okay, I want to print this message. Okay, at this point this message works, right? So what if we executed this and moved the ownership of this contract message to the closure itself, and we're trying to execute this? You see that this is becoming problematic because of borrow of moved value. So you're trying to borrow a moved value, so it's not going to work out. So if I run this, it's going to produce an error, say value borrowed here after move. Okay, so you can't borrow the value again, you've already moved it. See, variable moved due to use in closure. Okay, so these are some things you have to understand. For now, it doesn't make much sense to you, but what if I remove this here? You can see that because I did not move that ownership to this closure, I can have access to it. So let's run that. You can see that it executed successfully. So this is a legitimate example of using that is transferring ownership. Okay, in closures. Okay, so I think I like it this way, and it helps a lot. Okay, so we're going to discuss more about ownership, because it seems to be very complicated, ownership and borrowing. I'm going to break it down one step after the other, but before we do that, we'll need to first discuss about data structures. Okay, after data structures, we'll now have to talk about the various ownership ownership craziness in Rust. Okay, so let's run on this and verify that everything is working. So that is it, we have everything working. So in the next part of this video, let's discuss about data structures. So welcome to this module, and let us talk about data structures, okay, in Rust. So let's create a new file, call this module 4 data structures, and I'm gonna just bring it up here, just like I've always done. Say module, I need to import it first, make it a module. All right, and we have that module here. Okay, we don't have demo yet, but let's create a function for that. Public fn demo, and okay, everything is green. So now let's discuss about arrays first. Okay, so let's discuss about array. We're gonna call it fixed array system, because there are many ways how you can deal with arrays in Rust, and which is one of the things that I like. There was a programming language that I was using, and it was only stuck with a blockchain programming language. They only had fixed array, they didn't have dynamic array. Dynamic array is very important, which is what Solidity does have as well. It allows you to dynamically shrink or increase the size of array. So it's quite important that a blockchain network does have that. Okay, so let's define an array. This is going to be array examples. Okay, so we have array example here. So let's create an array. So we have a block, say block hashes. In blockchain we have these blocks and hashes. Okay, hashes are like the signatures, okay, that specifies a specific transactions, that indicates numbers of transactions. Okay, a transaction ID is basically the hash. Okay, so these are various hashes. Okay, and how you define it is by saying equal to, use the square bracket. This is just very much popular in basically every programming language. You have to use this square bracket to indicate arrays, and I'm glad that it's being kept the same all over here. So these are various hashes, so just numbers of blocks, you understand, numbers of transaction record. And you can see, because of this Rust analyzer, it helps me to automatically designate the type of array it is for me. So you can see that this is an array of integer 25 or 35, but I don't want it to be like this. I want it to be an unsigned integer, and I want it to be 64, because all this, there's not going to be a negative number in the transaction, so all of them are going to be positive. And you can see the size has already been fixed, it's been specified here. So this is how you define an array, a fixed array in in Rust. And you can print an array. You see, the way you print an array is a little bit different from the way you print a regular string or integer. So we say block hashes, okay, array, block hashes array, and we say this. Let me show you something. I'll say block hashes. Okay, if I save this, you can see that it's giving me error. You can see it doesn't implement standard display, standard format display. Okay, the format doesn't align with that, and it's telling me to use this format instead, or this format to to print it out. So let's do as it is recommended. So I'm going to put this here, this statement. So with that, let's pick this up and bring it up here. So let's see how it goes. So we'll run that. You can see the block hashes. This is the way it actually displays the array content for me, so that is cool. But if I don't want to do this, then I can, okay, let me just leave it like this. Okay, and if you want to access the first element of an array, it's just similar to how it's always has been in other programming language. So you just use the square bracket to access, to do 0, and you don't need to format it at this point, because what you're doing is an individual element. So this will give you the first element here. Okay, what about for the last element? To get the last element or the last block hash, you can decide to target it. This is 0, 1, 2, 3, 4, which will be 4, but this will not often be accurate, especially if the size of the array is increasing. So you need a different way, and I think there is some ways you can do it. For example, you say block hashes dot, they have multiple method that comes with an array. Say this is like first chunk, first, and there's also last as well. So if I say last, let me see. Okay, last, and then I say something like nah. Okay, I haven't used this one yet. So, but how you get this? Let's access the length of it. Let's use this method. So this will give you the length of the array, and then I subtract 1 from it. So this will give me, okay, I think why that didn't work out here is I'm going to do this for now, then I'm going to also do this again. This is, let's put this second. So block hash, at this point I'm just going to call the .last method and see how it is. Okay, let's try this again. Okay, that isn't working. Cannot index into value. Okay, this becomes an option, so it's because of the data type. All right, sorry, let's go back to here. So this is how you access the last member of this array. There are so many methods of an array that is encapsulated in this programming language. I don't know all of them, and obviously I'm only going to be using the one that I want to use. And if you ever have an issue where you have to use something different, you shouldn't be afraid of researching. That is part of the job of being a programmer. You have to be very researchful. Okay, so if I run this, run that, and you can see this is the first element and this is the last element of this array. Okay, so what about getting a slice of an array? Is also possible, which is one of the things I like about Rust. I used to underestimate Rust and just look at it as some kind of an ancient programming language, but apparently it isn't really that ancient, you understand. I think Rust was created 2008, so that is just when it was created. And I think if you just check, I think I have this faint thing, so which you can do. When was Rust programming language released and created? So let's check it out. So it was created 2006 and released 2010. So basically it's only 14 years since it's been released, because people consume it when it is released, not when it is in the lab. You understand? So it's been old. It's not been old. It's not an old language, but it's really making waves right now in the blockchain space. So that's one thing you must understand about Rust. So coming back here, want to get a slice of this array, and to get a slice of this array, we can say this is the block hash, this is the array, right? So want to get 1 to 4. Okay, so now it's giving me error. It's saying that the size value for type U64 cannot be known at compilation time. The trait size is not implemented for U64 on unsigned integer 64. All local variable must have a statically known size. Unsize locals are gated as an unstable feature. So what you can do to resolve this is by putting a reference symbol. This is you basically just referring that, so you're referencing the block hash, getting a copy. This makes you to have a copy of the array, itself. Okay, so a copy of the array, you're making a new array here. What this slice we get is something new compared to what was originally here. So this happens under the hood because Rust is very performant and very memory efficient, memory centered programming language, and it's trying to make sure that we don't have redundant stuff and we don't mess around. You understand? So when you program with Rust and you master Rust, it's going to really make you sharp. You understand? Okay, or make your project sharp, and faster. Apparently they have a framework for building web applications too, other than building smart contracts, which is really helpful as well. You can use that to build back-end services that are very highly performant. So we have slice block, so this is how we get slice. It's based on that range format, okay, that I've recently communicated with you as well, getting a range of items. So we're getting item from 1 to 4, okay, index of 1 to 3 basically, because it's not going to count this last one. Okay, so yeah, so we're going to get that slice and let's display it right here. So let's save that, run this. You can see that it got element from this, not 0 but 1 2 3, you understand, and didn't get 4. You can see clearly how that is. All right, this last entity here is not part of it. I think you can also say equal to right there if you want to get even the last until equal to 4. So those are some things you must bear in mind as you're working with Rust. So that's how you work with array, specifically fixed array, and this knowledge alone is enough for you to be able to write some code with array. And if you have any other information of what you want to do with an array, there is a bulk of method that you can access here. There is concatenation method, join method, align tools. There is so many methods. Binary search contains for you to use in checking if an array contains a certain element. Copy within, copy from slice, ends with fill. So many kinds of method that comes with this. You have split, all the methods. You have clone, there's just so many references that an array comes with. So you should check it out, if you have more, need of certain methods in an array. Okay, so we have another one called vector. Vectors are dynamic collection, so they are like dynamic array as well. So vectors, dynamic collection. So how do we create a vector here? So we say vector transaction, let's call it transaction IDs. Okay, and it's going to be a vector. This is how you define a vector, and a vector is basically an array still, but you can say it has one called tx1. This is transaction 1, This is tx2 and this is tx3. Okay, so you can see that this analyzer already tells you what kind of vector this is. So this is a vector of string slices. Okay, so I'm going to double click on it. You can see vector of string slices. All right, so I can do some abilities on these vectors, such as I want to add 2 more transactions to it. I can call this transaction ID dot push. So this is one feature that this does have. So you want to also check it out. Do we have dot push? You see, dot push is not available in a fixed array, so you don't have push method there, but you have that in a vector based data type, okay, or data structure. So what value I'll put in? Want to push in a value called tx4. Is it third transaction? So why now it's not working is because this one is immutable. So we need to make it mutable so that it can change. When we do that, you can see that it's allowing us to push. We want to also push a 5th one transaction. Okay, after that, we want to print out that entire array. So we can say after adding transactions, yeah. So this is basically how blockchain programming we go. It's just Rust programming, syntax, and all of that. So this is just doing. This is something similar to what you'll be doing in real life. Adding transactions to an array and then processing them or whatever you want to do. So with this, you can be able to. Okay, let's make sure that we're displaying this now. So I'm going to say this. So let's run that. Cargo run. You can see the transactions, all of the ones that are added as well. So what about to remove an item from the transaction? You can use this transaction IDs dot pop. Pop is a method for removing an item from a vector data structure. So, and this is possible because we're using this mutation keyword here. Okay, so this will remove that, and after removing the last element of the array, it's going to definitely become different. But let's run that again to display it. You can see that I removed that 5th one, and you can see that we only have 4 left. All right, so we can also iterate through an array. There is an iteration method for an array. So let's say you want to print out every item of the array. We can use a for loop. So for every transaction in this transaction ID, okay, in this transaction ID, we want to print the transaction ID basically. So I want to say let's run that. So we're able to print out the transaction IDs. You can also specify it by referencing just that transaction. So okay, and it will still work. So either way, okay, and this transaction is an array of strings. Okay, that is what it is. Okay, so I'm gonna remove this, keep it simple. Okay, so what if I want to access there is something called indexing. Okay, I want to access an element of a vector using indexing. All right, so how you do that is you want to combine this thing called if let. If let, remember we have something like that. So this will return, there's a keyword sum. I'm going to, when I come to option in module 8, I'm going to be discussing option, module 8 and module 9 and module Module 8, 9, 10, we're going to be discussing options and results, and you understand what this sum is, okay? So sum is basically used as a matching algorithm, something that we use in matching certain keyword values and so on. So we're using that to match. So we're saying that if sum, we're giving it passing a variable here. So if some first transaction, first transaction is equal to this transaction IDs dot get. This get helps us to access an element inside of the vector. So I'm going to access it, and it is seen as an option. So I'm going to pass this first. I want to get the first element of this index. So I'm accessing this index by so if the first element or this value that I'm trying to test against this first element here, if it is true, we want it to print out. You understand? Want it to print out a statement saying first transaction ID. All right. So because of the borrowing feature of move and blah blah blah, a lot of things about this thing, you can't just this. I think that is one of the reasons why we have to do this here. We want to make sure that whatever we're looping through here, it has to be a reference of this. You're borrowing. You're specifying that I'm borrowing this particular transaction without actually taking over the ownership. This is its own scope. So that is just what is happening here. So that we enable this transaction ID to still be available in this new scope that we're trying to use it here. So don't be confused if this is a little bit confusing for you. This is what is called sum. Sum is based on pattern matching in Rust. So we use that to match values. So this is used to match this value. You get this value, and to unwrap it, there's something called unwrapping, and all of these things we discuss with you later on. But sum helps to, if let and sum combine together, help us to successfully unwrap the value that is coming from here. Okay, if there is a value that is coming from here, that matches this pattern, all right, this first transaction that is of a string reference, okay, if it matches, then it will proceed by logging out this information. Otherwise, this whole block will be skipped. Okay, so it carries a safe mechanism of checking if a value is existent or not, if it does exist or it does not exist. If it does exist, it executes whatever block of code that is there. But if it doesn't exist, then it will skip that entire thing, ensuring that there is no error and crashes in your code. So it's a very safe way of determining the presence of value in your code. So we use this to check. All right, so we use it to check if this index at 0 has a value or not. Okay, and let's check it out now. Without further ado, I'm gonna run that. Okay, you can see that it printed that first transaction because it does exist. What if I say none here? It can't be, because this will not make sense anymore. So I don't want to complicate this for now. Let's just keep it simple, straightforward. Okay, so when the times come for me to explain this some the more, you will see so many examples and you won't have to be confused at all. So for now, we're going to move to the next data structure, which is actually called tuple. So this is tuple example. I'll close this here. Close this one as well. So recently we had a snapshot of how to create tuple, but tuple in a sense is like some kind of an associate array or an object, but not exactly like an object in JavaScript. So but it's quite useful for returning multiple results at once. So for example, if you have 3 different results that you want to return, then you can return it at once. So and it has a close relationship to being an array, but it's not exactly like an array. Okay, so let me show you examples. So I'm going to create a variable called user info, and we're going to call it, it's going to contain a name of somebody, a name of a user, let's say Alice, another 130, that is her age, and 2.5, that is her balance, token balance. Okay, so you have these values. You can make sure that it's typed this way, so yeah. After this, you want to print out that user information just like an array. Okay, just like an array, you need to format, you need to add this, this formatting feature to display the information of a tuple. Okay, so that's one thing you must take note of. And then you can also access each one of their information, separately. And let me show you how you do that. So say print line, and you can access the username by saying user info dot, it has this 01, to index format, just like it is with an array. You understand? So let's choose this one. Okay, so we can do that for the rest of it. Age and token balance, say 1, 2. All right, you can also destructure tuple, which is another cool feature that it has. So we can say something like let username, you can just say name, age, and balance be equal to that user info. So we can just destructure it that way, and it will just work out just fine. So we can use that to print out the individual information of that tuple. So this is how a tuple works in short. Okay, a tuple is a form of an array. It's basically helps you to return multiple kinds of data at once. Okay, let's test it out and see. Okay, run this cargo run. Okay, you can see this is the first set of information, which is this one here. Okay, and this is Alice, that is the username, age, balance, as you can see with these printouts, and the structured information, which is this. So the structuring is basically hand picking the information that you want to grab out from a data structure, such as an array, a tuple, or a vector whatsoever. All right, so let's jump into the next part, so let's discuss about hash map. Hash map are like key value pairs. Okay,
key value pairs, that will be a perfect definition of what an object is in JavaScript. Okay, it's more like an array of object or so. Okay, an array of object. It helps you. Do you know if you have used Solidity, if you have mapping, okay, that is what a hash map is, in this example. So let me show you what it means. Let me show you how a hash map operates. So let's say, just like an array, a vector, a hash map is dynamic. You understand? It can grow, it can shrink. So you need to specify a mutation here. Okay, so you can say balances. In Solidity, you have something like balance of, okay, which is also the same thing here, where we have balance of different, individuals. So balances is equal to a hash map, and a hash map. If I insert this here, it comes from this library. Okay, this is a standard library that comes with Rust. Okay, so you don't need to install this to have this functioning. So long as it came from the standard library that comes with Rust. Okay, so it is inbuilt. Okay, so I will use this to define a new hash map. Okay, and we need to specify the type. Okay, for example, if we want to see each name of a person, would be associated with their token balance. That would be something like, let's say, a string, a slice of string, str, associated with their token balance, which would be something like unsigned integer U32. Okay, so this could also be something like the user wallet address assigned to this. I think we can do something like that. So let's just do balance of. Okay, let's use that Solidity pattern. Say balance of. You call .insert. The .insert helps you to put together to insert a value inside the hash map. Okay, so let me get a wallet address that we can use for this example. So I want to insert this as having a certain amount of token, let's say 100, and we can have more, like, let's see, another account, insert another one. Let's say this one has 150, and let's have another account. Okay, and this one, we'll say it has. This is how you insert or add item to it. It's very much structured. It's very clean, straightforward. And then you can print the user balances. Okay, now if you want to print a hash map, just like with Tuple or any of this data structure, you have to use this format keyword. Okay, this hash format thing. Okay, so you need to do that to print this thing properly. So at this point, but what if I remove this? If I do this, then I can't print out this, because this insertion, we have an issue. Minus this balance is balance of. Okay, you see that this insertion is not going to work out, because if you're growing that hash map, then it needs to have a mutation keyword attached to it. So that's what it simply means. And at this point, let's test out this particular example. So save this, run. You can see that. Okay, I think there's a certain format of having a prettier form of this. You can see that that is even much prettier. I like the way it's well formatted now, so this is cool. This is how you print out the content of a hash map, and this is how hash map is. Okay, if I come back here and let's see this first ID, you can see it here. I'm going to give it another one. Let's say I try to do that. It should not happen, but let's say I try to give it 300, and let's run that. You see that it refused to insert that again because it's already it just updated the existing one. It just basically updated the existing one with this first one. It updated it with the new value, so it does not allow for duplications. Okay, it doesn't allow for duplicate entries. It allows for one element per a key. So this is the key and this is the value. So this key, there can only be one key. It can be two different keys, but it can have as many values the same as you want, but it has to be one key. Okay, so what about accessing the value of a hash map? This is how you do it. You can use match. So remember, match is basically an if statement format. Okay, so trying to match or try to test this balance of dot get. I want to get, sorry, I want to get this key, so I have to target the key. Okay, so I want to get this key. So if that, make sure you come here. Sorry. At this point, if there is any value, okay, I'm going to use this sum, this option based matching. So this sum helps me to match something very well. So if there is a balance of, okay, so I'm going to call this balance. If there is a balance, okay, if there is a balance for this value, then it should just print something like the balance for me. Okay, otherwise, if there is no balance, okay, then it should just print out simple information such as no balance for found for this user. You get that? So if I put a right, let's just test it out without having to talk too much. So let's run this. You can see that there's a balance, for Alice, or whatever I'm supposed to call it, balance, user balance, that is it. But what if I am using a different key, like adding extra one to it, so it's not really exactly same key? So you can see here that no balance found for this particular user. So that is how hash map works. What about iterating over hash maps? Since it's a data structure and it can come as an array, there is a way it has indexes. No, it doesn't have index like that of array. Okay, array has index from 0 to infinity, and that is how you track and iterate over it. The same thing with Tuple. Tuple has index from 0 to as many as possible, so you can use that to iterate through those data structures, including vector. But for a hash map, the key is different, so you have to be the one to iterate over it yourself. So and you can use a for loop. All right, so this is how it works with Rust. I don't know, but Rust kind of does it a lot simpler than even Solidity. I like the fact that since it's a key value pair, I could just say something like the user and his balance. Okay, so the user is the key and the balance is the value. In this, remember, you have to use, because of the principle of ownership and borrowing, you want to use a reference instead. So reference to balance off, so that you don't modify, or you don't have the ownership, and then when someone trying to print out this again, you not have an error. So you want to print out the balance of this user, so this is just pretty straightforward. Okay, in Solidity, I have to devise a certain way of tracking these, making sure that I have a certain number. Like, it's just crazy. Okay, but with this, it's kind of straightforward. I like the way it is, just specified here, like using this for loop, and you can destructure it, the value, and then just loop through it and display the result. So let's test it out and see. Okay, you can see here that these are individual values that are in that balance of. Fantastic. What about updating the record of a hash map? Okay, because remember, we can override the record, like I have shown you before, using the insert and reinserting something. That is cool in situations where it is cool to a certain extent. It kind of prevents error, but there's some blockchain language, programming language, that if you do this again without you observing if this is already a key as you wanted to insert is already present in that hash map, then it will produce error. So I like the way Rust actually handles that error without handles that situation without having to bust me with some weird errors. Okay, so let's look at it here. So we can use say balance of dot entries, this entry keyword. For this entry keyword, you want to check if this key exists. If this key exists, then you want to modify it, say, and modify it. Has this feature as part of it already. So, and this feature basically takes in, you can pass in a closure. Okay, you can pass in a closure, which is basically a function. Okay, you can pass in a function inside of it and perform some activity. So, but I'm going to pass, in this case, I'm going to pass in a closure here, and the closure is, I'm going to access the current balance. So at this point, we want to access this balance that was passed in from this entry, so, and if you want to modify this balance, then you have to dereference it, because the idea of closure, it needs to have access, like ownership or reference, to a proper one, to whatever you're passing to it. Otherwise, it's the principle of ownership and borrowing, which I'm going to discuss in details, as we head to module 5. You find out why all these are very important. So I have to dereference this balance here, and I'm going to show you how I dereference it soon. And I will remove 50 from the balance. Okay, and update, and just print out this information here. So you see, but you see that I'm having an issue now. It's a balance of. You see, I'm having an issue now because this is complaining cannot mutate immutable variable balance. So this balance is an immutable variable, and you know that it's being passed by the value that was present in this balance, of, okay, when you access or when you get this value. So if you want to modify it, then you need to dereference this. You can see here saying binary assignment operator cannot be applied to type and mute reference of U32. Okay, so we'll say cannot use underscore type, So it's telling you that if you dereference the left hand with side, this star, then you can be able to perform this operation. So I have to put star in front of this. When you save that, you can see that I can now perform that operation just fine. So let's run that. You can see this now. I have to put this way. This is the best. It's a prettier way of, printing out something. So these are the updated balance. So I don't know. Say updated users balance. Okay. So now, what if you want to remove a key, okay, from this balance of you want to remove it? There is also a method for doing that. It's one of the things that a hash map does have. So you can quickly do that by saying balance of dot remove. Okay, it's more like the way an array has a push and a pop method. Okay, so this is like a pop method. I want to remove this value, this last one. So make sure that it is, and you can say that I'm gonna come here, print this, say after removing user, this is what you get. Let's run that again. This is what you get now at the end of it. So this is how a tuple works. You can see how we create a tuple. This is how a hash map works. You can see how we created the hash map. You can see how we insert value into it. You can see how we printed it, and then you can see how we access and match some values inside of it. This step is necessary if you want to confirm if a certain value exists inside of it or not. And you can also see how you can loop through it. You can see how you can update it. You can see how you can remove item from it. So that is what it is about, tuple. There is also other method that you can find here. If I say balance of and say dot clear is to remove everything from it, contains key, we return a boolean. So you can see here, you can use this to perform, if that value contains a certain key reference. You can see various things. This will help you to get the key value of the tuple. You can say check if it is empty or not. You can check the length of it. It has just rich, you can even grab all the values instead of, and this could be very fun, useful in case you want to convert it into an array. So you can get the keys of you can get the keys, you can clone it, and you can do so many kinds of things with it. So that is it for tuple for now, hash map for now. So let's jump into nested data structure. So if I come here and say public, because the funny thing is that you can have within a hash map, you can have an array or a vector. You can have a tuple. You can just have various kinds of crazy combination, and that brings about power. So and for example, let me show you an example. If I have a voting application like a Dapp that a lot of people voted, let's say each vote, each election can be put, or each poll can be put into a hash map, and all the voters can be a vector inside that particular pool. So you can see how it can be useful. So for example, let's have, you have to use Mutable if you want to grow and shrink a vector or a hash map. So let's say user transaction transactions. Okay, user transaction is equal to a hash map. You want to create a new hash map. Okay, now for this new hash map, it's going to be for every key. Okay, the key is going to be like a string, it's a slice of a string where you target, just like we have with a key, a user ID that is targeting a wallet, user wallet that is targeting or its record, the user's balance. So for this one, we're having a user's string or whatever. It could be a name, it could be a transaction ID, it could be a wallet address, whatsoever it is. You want to use that to, it's going to lead you to a vector. Okay, now this vector will be like, vector must contain certain kinds of values. Okay, if it's a vector of strings, if it's a vector of numbers, if it's a vector of floats, whatsoever, vectors of boolean, it doesn't matter. So but this case is going to be a vector of string. Okay, so that is what it is. So a hash map that contains a vector. A hash map, I think, can also contain another hash map inside of it. So it's called nested data structure. That's why we have in Solidity, we have nested mappings, okay? Or I call it two-dimensional mapping. And I will recommend that you keep this thing at two-dimensional range, instead of keep nesting and nesting. It could become, problematic for you to manage that. Okay, so I'm going to come here. Let's insert a new transaction. This, I'll say dot insert, into this. I will say, let's say Alice. Okay, and no, let's use that same example that we previously had. So I'm going to say this user has these transactions. Okay, and how you put a vector is by saying this vec keyword, and then you can have all the transactions that are performed by that user. So we have tx1, 2, 3. Okay, so we also have another one that has this fifth transaction and this fifth, fourth, and fifth transaction. So let's grab this wallet address. All right, so these are two. Okay, so these are transactions that belong to each one of these users. Okay, so let's print out those transactions in details. Let's see how it is. So I'm going to do this. I'll use this hash symbol to make it prettier. Let's print out this. So let's run that and see. Run. You can see their details. You can see these are transactions. For this, you can see how many transactions this has. You can see how many transactions this other one has. That is one fantastic example of using a nested, nested data structure, such as with hash map and whether tuple hash map and vector hash map and array and an array, whatsoever that you want. Okay, so let's check another one. So let's do another matching. We can access the value of a nested hash map using this if let sum, which you're using to check if there is a value. Okay, if there is a value, then it should, if that key has a value, it should print it out. But if it doesn't have that value, it should just completely skip that whole line, that whole block of code, that idea. So let's get it together. So for example, if say let sum, so this sum here, I'm using it to check if there is a value for this transaction. Say transactions, Okay, so I'm gonna go through this user say dot get, that is how we get a value out of it. And I want to grab this dot get this and dot get this. If it does exist, if there is a value that exists, it's going to print out this line of code right here. So I'm going to print it out here. Otherwise it would not even bother. Okay, so user transaction, it will then print it out. Otherwise it won't print, it will just keep this entire block of code. So is a handy use of an if condition, an if condition. If something matches, if we have a match for, there's a value for this particular key, then it should proceed with rendering this result. Otherwise it should just let go of it altogether. So now let's check it out. So I'm gonna run this so you can see this is the user's transaction if it is found. But if it isn't found, let's say I add one here, let's see, you can see that it didn't even bother throwing up anything. It's a way of handling error. If something is not found, it just gives you a fantastic way of handling an error situation with accessing the value of whether a nested hash map or a hash map in total. Okay, so lastly, let's add new transaction for this guy here. Okay, so how do we add new transaction? Not new record, not rewrite the entire record, but just a single, add one more transaction into here. So how we do that is by saying if, we're using that let sum if it is found. Okay, so let's just take this entire thing. I'm gonna come back here. Sorry. Okay, so this is a transaction. If when I want to get this transaction, there's something called get mute. Okay, it will return a mutable reference, of that transaction. So it means that I will be able to modify this transaction within this space. Okay, so that is what it means by, remember here that hash map is not mutable. This vector is not mutable, but this hash map, this hash map is mutable. So if you want to modify the content of each transaction, the transactions array, you have to find a way of making it mutable. You understand? So that's why this is called get mute. Okay, so because it's going to return a value that you can mutate. Okay, so I'll say this transaction now, I'll call on the .push method. Okay, what I'm pushing is a sys transaction. Okay, so after I've done this, I can print out the transactions. Where are you? So let's print out this transaction. Say users transaction. Okay, so let's save that and run this. So you can see that these transactions now have a sys. This user now has a sys transaction, and that is how you manipulate these are the various data structures, and that is how you manipulate a nested, a nested hash map. I'm sure there is a lot of use case where this is going to be needed for you, and this is how you can have various examples with it. Now, why we're doing all these things is when we want to start writing smart contracts in any programming language, any blockchain network that uses Rust, this will become a foundational, tutorial or course for you to use in following us that, because you won't expect us to be teaching you Rust when we are working with SDKs, Rust SDKs and the various blockchain networks and all that. This principle will be all grounded into you by then. So let's, check out, let's perform the entire operation here. You can see all of those, things that we've been doing listed down. Okay, so let me also see. Okay, yep. So there we go. That is for module 4. So let's jump into module 5, where we discuss about ownership, borrowing. So let's create a new file. Let's work on ownership and borrowing. So I'm going to create a new file here. I'll call it module 5 ownership and ownership example, but it also contains borrowing. I'm going to discuss that concept with you. So let's get a basic example and discuss it in detail. So I'm going to also have another function called demo, and come here, call this module 5. So right here, let me show you something. In Rust is memory efficient and memory driven. So if, for example, in other programming language, if I see something like let token owner equal to, say, string from, let's call this Alice. Okay, in this example, who owns this value here? The owner of this value called Alice is this token owner, this variable. So this variable basically owns this content. Okay, this is the principle of ownership and borrowing. So I need you to understand that this value called Alice belongs to this variable called token owner. Now let's say new owner. Okay, if I say token owner, in regular programming, let's say with JavaScript, your thought will be that this is just a duplicate, you understand, a copy of this value. It will look like we're copying this value and we're just pasting it here. This, what you just see right now, is not the same as it's not the same as this. Okay, this is not equal to this here. Okay, so the way this is exactly the same, is the value that is stored here, but this one is a totally different value. So the difference is that the location where these values are stored in the database, they are different. So let's say, for example, this one is stored on in memory location called 4th Avenue. Okay, so this is where this value is stored. When you're referencing this one here is also referring to a value stored in 4th Avenue. Do you get it? It's not creating something new, it's just grabbing the same value because it knows that this one is referencing is referencing the value that is stored that belongs to this token owner. But here, this one is stored in another memory location called 6th Avenue. Do you understand it now? That this one is not the same as this one. So that is the principle of, of ownership and borrowing. Now that I've described that for you, let me comment this out. When I print out, let me say I print out this new owner. Let's come here. So I need to make sure that I comment these ones there out so that it will not be bothering us with so many this, and let's say old owner. Okay, this is okay. So you can see that I'm still trying to access the content of this here, and it's giving me an error because what happened here, the moment that I gave this new token owner the content or the value of the old token owner, okay, it now became the new owner. So this doesn't have the right to come and print out this like this way. Okay, it doesn't have the right to print this anymore. Why? It says that borrow of moved value. So this value that belonged to this old token originally has been moved to this new token, so it doesn't have it anymore. So even though it's trying to borrow it, it's not there. You understand? So value borrowed here after moved. So you're trying to reference this after you've moved it. Okay, so error originating from so the best way to resolve this is by cloning it. Okay, and I think there's also the process of assigning it as a reference. You understand? This is borrowing. You understand? You are not taking over the ownership, but you're just borrowing the content. So it's more like I'm just borrowing this, or I'm just mirroring your content, but I'm not taking over the ownership. So that is why you add this symbol in front of this token owner whenever you're assigning it. But if you don't, then you're passing over that ownership to this. So this is very important if you want to succeed in Rust. You need to understand and master the principle of ownership and borrowing of values. All right, so at this point it will result, the new owner will work. So these are some things that you should understand about borrowing and ownership. Okay, so I know that you may have more questions, but you can just do a simple research yourself and you can have more understanding. But if you got what I meant by the way Rust treats variable is that if you assign another variable to a new variable, you've transferred the ownership along with that assignment. But if you just pass in a reference of it instead, you have not transferred the ownership. You only mirrored the value of it. That is just what happened. So these differences matters a lot as you're moving forward with Rust, and that is a lot of the reasons why you see me talk about move. I'm going to tell you about borrowing. I'm going to tell you about ownership soon. So these are the information that you need to know. So why does Rust do this? It's doing this so that you will not have to recreate this value that is already there in the memory over and over and over again. Like if I do this, for example, you see this value is already here, so why recreate it and have it occupy another space in 6th Avenue when it's already in 4th Avenue? To conserve space, Rust have this memory management system where it just
instead of you recreating this, it's better that you refer to the one that has already been stored in the fourth avenue. So those are just some basic memory management tactics that this particular programming language called Rust employs to reduce, memory loss. Okay, so and it make your application faster, and with all these things under the hood, Rust is just very great. Most of these things, like you can see how this string, I've not even typed, made this thing a type, giving them a type, you understand? And Rust is already doing that for me under the hood, because the compiler by default, is memory management, oriented, memory efficiency oriented. Okay, so let's, I think a word is enough for the wise right there. So let's I've shown you ownership and borrowing just in a nutshell, but I'm going to come back to that borrowing later on. But if you want to, there's something called cloning. Okay, knowing that you cannot assign the content of a variable to a new owner without also transferring the ownership of it to that new variable, then how do I get a new value? Okay, how do I give a new variable the same value without transferring the ownership to it? There's one of the principle called cloning. Okay, cloning helps us to do that. Okay, but remember, if you're cloning, you're sacrificing memory, and it has to be for an important reason. If you're going to duplicate a value, then it must be for an important reason. Otherwise, it's better that you just borrow the value. I'm not going to show you more about borrowing when we go back down the line. So, but for example, we have this transaction ID here, and we're just getting a string. This is just a string right here. The ownership of this variable or this value belongs to this transaction ID. So now I want to copy it. To copy this, I could do, let's say, let transaction ID copy be equal to this transaction ID dot clone. Okay, if I call this clone method, okay, then these two are different owners of the same value. So what I just did was to clone this, so it's stored differently on the memory. So this one is stored in 4th Avenue, and this one is stored in 6th Avenue. Okay, so that is it makes sense for you right there. So that is why we have cloning abilities. So if I if I print this, it will not give you that error that it used to give you in this ownership thing. But the moment that I remove this, it's definitely going to give you that error. But if I cloned it successfully, it should work just fine. Sorry, this should be transaction copy. Okay, so let's do this, and let's print it out and see that everything works. You can see the original transaction and the copy transaction or the clone transaction. So that works just fine. Remember, if I remove this here, if I say I don't want to clone, it's going to result in an error because of it will violate the principle of ownership. You understand? Let's copy trait. There is also some traits, and I'm going to discuss about traits in module 11, so you will understand trait. But trait is just characteristics. Okay, and this is quite prominent in object-oriented programming. The characteristics of a parent or whatsoever. You understand? So let's go and copy traits. So let's have that example. So in this example, let's have a token amount. Okay, simply I have this token amount here, and I've copied that token. But this copying it actually transferred the ownership of this amount into this new one here. So that is what I just did. And if I want to print this without having that error thing, so if I say print line, and say
the original. This is the original token amount, and the copy token amount. So which be token amount and token amount. So this seems to work. To string. If I say to string here, and you see, so what is happening here? The difference between this being a string, because if it's string based, it's gonna, violate what is called the ownership rule. Okay, this string, okay, or this particular string here, okay, is a string that is created with an ownership. Okay, it is quite different if I say something like this. It's quite different if I say something like this is string slice. You understand? A string slice will work just fine, but so long as it's an ownership based string, if I say dot to string, it's going to produce an error. So there's some certain data type that have ownership by default, and some others don't have ownership by default. You understand that? So if you're working with those ones that don't have ownership by default, like this string slice, this operation will work just fine. You understand that? So that's why if I use this unsigned integer this way, it works just fine and it doesn't violate the principle of this. So basically what we're only copying here is the trait here. Okay, so to simply explain better, you should understand that why this does not violate the ownership principle is because data type that are of primitive, you understand, the primitive data types such as integers, floats, string, slice, boolean, okay, these ones implement copy. They implement the copy trait, okay, but the moment you are discussing about this string, it does not implement the copy trait. So and the copy trait has a way of managing ownership under the hood by just basically creating this or duplicating it. It's a bitwise operation, and it happens under the hood, managed by the compiler itself. So long as it's a primitive data type, this rule is applicable, and what you're basically copying only is the trait. You understand? I don't know if you get that, but just understand that there is borrowing, there is ownership. Okay, I'm going to show you more about borrowing soon, but every variable that contains a value is the owner of that variable, or it is the owner of that variable. And if you want to give it to another, depending if that variable or the type of that variable is a primitive type or not. If it's a primitive type, the compiler will manage that ownership thing under the hood by copying the traits of that value. Meanwhile, if it's not a primitive data type, you will have to find a different way. You have to use a different way to transfer that ownership or to refer that, because if you give a new the old ownership to a new variable, then the old variable loses the ownership of that and can no longer access that value. I hope that makes sense for you. That this concept alone is very complicated. When you try to explain it, in Rust. I think it's going to really require some visual aid to make it even more lively. So let's run that. See, this is working. This is the original token. This is the copied token. Okay, what is being copied is the trait and is managed by the compiler under the hood by doing some bitwise operation, blah blah blah. You understand that? So in this case, let's jump into the next part of this, which is borrowing. Now let me show you about borrowing. Okay, now you've seen about ownership. Okay, but let me tell you about borrowing. For example, this right here is a string that is legitimately owned by this variable called contract state. If I want to borrow the value of this, to another variable, let's say new contract, I can, if I say something like, if I assign the old contract state to read, then the ownership of this will belong to what's it called? If I say print, if I want to still print contract state here, let me come here. You see that it's no longer the owner of these. It's no longer the owner of this value here, so it's going to result in problem. Remember that thing that I discussed about. So for you to borrow, this is what borrowing means. For you to borrow the content of this without also grabbing the ownership of this, you have to put this ampersand, this ampersand in front of it here, and that resolves it. And and with that, I can operate those two things without having this sort of error. In fact, I could come here. Let's come here, say print line, and just print out this one here. And for you to print this properly, you have to use another printing format called print borrow. So I'm going to create that function soon. So let's create a function called print borrow. Okay, I'm going to create that here. Print borrow. So this function is going to help us to print out borrowed variables, okay, borrowed values. So, and I need to make sure that it's a contract, and it has to be a string reference, okay, a borrowed string, okay, because this is a symbol for borrowing, okay. So I'm basically referencing it. So a borrowed string, and I just want to print out, that borrowed string. Okay, so this contract here, I'm going to just print it out. So right now, I could come here and do this. Okay, so if I print borrow, this should work out just fine. Now copy this, duplicate that, paste it. Let's run that, and you see this is borrowed contract. It's working, and after borrowing, everything works just fine. Okay, so remember, there are two ways you can do this. You can decide to use a function this way, or you can assign it to a variable by saying contract. I just call it contract here, and you just see this ampersand contract state. Okay, so when you borrow this, then you can just print out this value, that calling this. So we can print out this value here. If I run this, you can see all of them are borrowed. So this is how you do it. Okay, you borrow the value of another variable by using that ampersand in front of it. So I've explained myself pretty much clear. So I'm gonna just do this now. Boom. Okay, so at this point, let's jump into mutable borrowing example. Okay, so these ones we've been working with are immutable, so I can't come and change the value of that. I can't modify the value. I only have to reference it. It's more like a read-only operation. So what if I want to do a read-write operation? Okay, so that is what we're talking about here, mutable borrowing example. So again, I'm going to grab this, going to create something like this, but in this case, I'm putting a mutable clause in front of it, unlike here when it doesn't have a mutable clause on it. So this is a string that has ownership rights, and this variable has that ownership right, and I'm putting a mutable in front of it. So I want to modify its content. So to modify its content, let me create another function, call it modify state. Okay, now in this modify state, instead of just having this contract passed here, it's going to also have a mutable clause. Okay, so we have a mutable string, a mutable borrowed string. That's what is going to be passed in here. And at this point, I can do something to this string. I could say this string now that is coming dot push string. So I could add something to it, like say and now active. Okay, so I have modified the content of this string because of this alone here. So when I'm calling this here, I could then pass in here modify state and pass this contract state, because it's a mutable. If I do something like this, it will not work out because it's an immutable variable, but with this it will work out because it's a mutable variable. So with this I can then print out the value afterward. You find out that this value, this original value, has been modified. So you can see I'm going to print it out, and I'm going to access this. This function went in and changed the value of this. That is one funny thing about Rust. Okay, because of the principle of borrowing and ownership. So let's do this, run that, and I'm going to explain more. So you can see that after modifying, the contract state is now contract pending and now active. So it's now active. So let me explain this a little bit more. We created a mutable string here, a mutable owned string here. This is owned string. Okay, by the way we defined it here, it means that it has been owned by this variable here, and we'll make sure that this variable is mutable. Now we modify this by creating a function that accepts a mutable reference of the owned string. Okay, so we pass it and give it the right to modify, to mutate, the right to mutate the main string variable itself. So with that right, it can come and modify the content of it. And because of the principle of ownership, whatever that is being done to this value that is passed is being done at the address of, remember this is where is that example? Okay, so this is 4th Avenue. So let's say this is stored at 4th Avenue. So when this modification is done, say modification done at 4th Avenue. So it's done at this particular avenue. So it's changing the content at that location and not just a copy of it. There is no copy here. This is modifying the content of this at this particular location. So that is just the principle of ownership. So if something has been owned, you want to change the content of it, you have to have the ownership right. You have to have that borrowed mutation right. You understand? So you don't own it, but you just have a right to change its content. This is still the owner of this particular value here, and this is still the owner of this particular value here. It's just that this function has been given the right to make some modification on this string here. So that is what it is. Okay, and in that case, we're kind of done with this. There's also some concept that I feel like you should read up, and one of it is called the Dangling Reference example. I the dangling reference example. Okay, so let me just give you an example of what a dangling reference is. So I'm going to create an example here. Okay, and let's call it dangling reference, and we want to create another function called, okay, this function called invalid borrow. So this function returns a string reference. Now for this string reference, let's say S, which is the string reference, say I will be dropped. Okay, this string reference is dropped. Let me say it's supposed to return this S, because this is a local variable, this S here, and at the end of the function it gets dropped. Okay, so at the end of this execution of this function it gets dropped, so it's basically not going to be available. So if you try to say let, for example, invalid reference is equal to invalid borrow, okay, and you try to print out this value here, it isn't just going to work out. Okay, so let me just do this quickly. Cargo run. So cannot return reference to local variable S. So the problem is based on the idea that this S is created inside of this, so trying to return it doesn't just work out. So it doesn't get returned. You understand that? So now this because this thing is not saved in the memory, so because this S is not located in the memory, or at least you can't have access to this string. Now this creates a dangling effect on this invalid reference, because this reference is not found, it's not in the memory. Okay, it has been removed in the memory, so it's not found in the memory. So you're trying to access it, it won't work because this has been removed or deallocated from the memory, and this causes what is called the dangling effect. This is a big issue, if you make this sort of mistake. So using this opportunity to let you know that you should not do this sort of mistake. If something is not there in the memory and you're trying to access it in any other place, if, for example, if it is freed, if it is dropped, if it is deallocated, if it is moved, you understand that, then it will occur in that dangling situation. So to correctly do this is by making sure that this returns. You understand? If that returns, you see that the drop is, this is a valid string. Okay, but if you can try to get the reference of something that is not committed into the memory, okay, then this is where the problem arises. So that is what it is. Okay, so that is just what I want to use in describing the dangling effect to you. Okay, so it's something that, of course, you're not just going to bump into and start violating, so we can be cool with that. Okay, so let's work on module, call this module 6. Okay, all right, so as usual, we need a public function called demo. Okay, and have it imported here. Module 6. Say module 6. All right, so now, like I did mention at the end of the last module, that Struct is a custom built
data type or data structure. The data type basically, you are customizing it, using all the provisions that the specific programming language provides you. Okay, so that is what we're doing. For this example, let's start with creating a struct. And if you want to create a struct, which is a custom data type, use this keyword called struct. And if you're quite familiar with Solidity, this is not a new concept. Even in TypeScript, you have things like interface and types, right? So that is what this particular thing serves. Okay, so you have a struct, and before we go there, let's come here first. Okay, so we're right there. Let's build this custom structure. Call it blockchain user. Okay, what constitutes this blockchain user? A blockchain user has a username, which is going to be a string. Okay, it has a public key, which is going to be a string as well. This public key is their wallet address, and they have a balance, which is unsigned integer 64, and lastly they have a status, whether they are active or inactive, which is a boolean in this case. So now that we have that, we can create a user using this information. So we can say want to make sure that it's mutable. Mute user1 be equal to this blockchain user, and then I'm creating this blockchain user. You can then pass information such as the username could be, let's say, Daltonic, the public key 0x something, something like short. Balance is actually, let's say, 300, and lastly we have true for activeness. So this is how you create a user. And if I should print this user now, okay, I'll say blockchain user and make sure that it is pretty much formatted, and we can say this user1. So let us print this out and see. Oops, what is going on here? I made a mistake. I am addressing it as if it is a tuple. It's not a tuple, so I'm supposed to refer it as a struct. Okay, so, and how you do that? By using a curly brace, and you say username, you say public key, more like an object in JavaScript, you say balance, and you say active here, and make sure you end this with a semicolon. You need to make sure that you convert this thing to string. You can say to string, or you can use this version called string from, then use that. So that will resolve it. And what else? It's having an issue. It's saying that I need to use this derivative method here for this struct. If I don't use that, I can't print it out properly. So I need to make sure that that is specified. So for now, I'm not modifying it, so I'm going to keep it like this. So let us run that again now. So you can see that these are the information about this blockchain user. So this is how you basically access, print out this thing, and you can, print out any information that is inside it by just using this dot notation. So, but this is not where we want to end. So we're saying, for us to make this particular blockchain, this structure, a lot more creative, we want to add some certain, traits to it, some certain abilities to it. So, so that is what is called implement. You understand? Implementation comes in. Implementation is a keyword that is unique to Rust, and it gives a structure, an ability, to do certain functionalities. Okay, so for example, we want to give it ability to create new blockchain user, give it an ability to display an existing information about a blockchain user, and want to also give it the ability to update the public key or any other information about it, and also the ability to deactivate or increase the balance of those. So we want to give all those information, all those abilities. We do implement. This is a functionality that is built on the Rust programming language. So when you do implement, you reference the structure that you want to do some modification on, and then you give it some ability. So the ability is basically a function. So the name of this function is called new, and what this function does is to accept the reference, okay, the reference of the username, the public key, and the balance, references of them. So I'm going to put that here. Okay, you can see this is a string. It takes it doesn't sorry, not a reference. It takes a string slice one. It also takes a string public key is also a string slice, and the balance is an unsigned integer 64. So these are all primitive types, and it should return self. Basically, that particular should return that a blockchain user. That is what it means. Self means return a blockchain user. And then now this self, I would define it. This self now, we're going to use that to string, you can say username dot to string. Okay, username dot to string. You want public key, you can say string from public key here. Okay, you can basically do the same thing here. I'm just trying to show some diversity, username. Okay, and the balance is going to be whatever you send here as balance. And the cool thing is that you can just shorten it like this, which is one of the features that JavaScript does have. When the key and the value, the key and the variable carrying the value are the same, you can just name them one thing, and then this one can be true as default. So this will help us to create a new object. Okay, and it is now part of the functionality of this struct. Okay, so now let's create another function, another ability. So call it function display underscore info, and what you're going to pass in here is self. Basically, it's going to be reading that specific blockchain user. Okay, so self here. All right, so what we want to print out the information about that blockchain user, which will be, sorry. Okay, so I'm printing out the username, self.username, self.public, and self.balance, and all that. So I'm just going to say name here. So that is what this simply does. Okay, and what else? We also need the ability to update an existing user. So we're not updating everything about them. We are only updating, say, update underscore public key. So we're only updating the public key. So I'm going to do this. So basically, we need to pass in self, that self. But now, because we want to modify this self, we need to pass it as a mutation. Okay, we need to pass it as a mutation. Otherwise, we will not be able to change, information about this, any record about this particular blockchain user. Okay, so when I say self dot public key, and you want to update it with this one called, I could do stro dot to public key dot to string. Okay, this is just what it does, and it will update it. And lastly, we want to be able to deactivate, not lastly though, but say deactivate. Okay, in deactivation, what we need is that self only, that particular user. Of course, you want to mutate something about it, so I'm saying active is now equal to false. And lastly, you want to add. I think add would be much better to use this function. So say add balance. So these are various abilities that we're giving to this blockchain user, struct. It's just like that, nothing more. So I'm going to also specify the amount that I want to use in modifying. This is going to be an unsigned integer, u64. Okay, so we'll come here, this self dot balance. We're going to top it up with the amount, and also print out something saying that you can say added tokens to user. So this token and then the username. All right, so that will be it, for all the functionalities that I want to give to this blockchain user right here. So now let's go and revise how we're doing this. So instead of doing this now, we're just going to consult this new function to do it for us. Okay, so that's what we want to do now. And to implement that, we're going to say, instead of, I would say user2, I say this should be, I'm just going to call this user, instead of, just any user. So I'm going to do that to show you how the difference between the two. So say user1 is equal to this blockchain user, but now I'm going to just call the new function, which is really cool. You see how straightforward it is. And I need to pass the username to be Daltonic, and the public key is this string slice, and the balance is 300. So this basically just it does all these things for you, which is a lot more cleaner, very clean compared to this. And to display this result, you can just call on user1 dot display info, and that will just do exactly the same thing as here for you. So let's run that. Okay, so unknown field, it's not, I made a mistake here, it's called active, not actis, active. Okay, so need to change it wherever we have that. Okay, so let's run that again. So you can see the information is being displayed, exactly the same information as this. So you see, this is how you create a what's it called, this is how you consume a struct. You can use that to just create it barebone and manage it yourself, or you can implement some functions around it that will enable you to manage that structure very well. I think this is a lot much cleaner, a lot much great, and it's so cool that I feel like you can even move all these structs into their own specific module, and that will give you like a definition or a structure on how you manage your project. This is really cool if you ask me. All right, so what about, let's update some information. I think we don't need this anymore for now. Okay, don't need this anymore for now. So let us do this. Let's update the public key. So I want to say user 1 dot update public key, and we want to give it a new public key, and let's call it this. So this is the public key. So I'm having an issue here. Okay, so the issue is coming because remember I removed this mutability. I removed it a while ago. So as I've removed it, you see how that error is gone. So after I had updated this with this new key, remember this is the original key, public key, but now with this, let's run that again and see the difference. You can see this was the previous key and this is the new key. So the updating of user information is working just fine. And what if I want to deactivate? Okay, so let me perform a deactivation. So say user 1 dot deactivate, and if I call on this display information again, you see that this has been deactivated a little bit. You can see that before it was active true, but now it's active is false. So that same struct now have all these abilities. Okay, this is pretty cool, and that is just how you give abilities to a struct and make it more richer, and implementation method more straightforward, streamlined, and better for everyone. So at this point, we want to do other stuff, such as we want to also use struct to simulate transactions with tuples. So let me just show you an example here. Let's create another struct. I'm going to close this here. Another structure, and this one is called transaction. Okay, transaction. Say struct. Remember that this is a struct that is based on defining this object, but there is also a struct that is based on tuple. Okay, a tuple based struct. So what I mean by that, I could just do transactions, for example, and say that transaction must contain an unsigned integer 64 and a string. So this is a structure right here. It's the same thing as this, but not exactly. Not exactly. This one has a key value pair, defined key, but this one doesn't have a defined key. It's just value based. Okay, so this is another way you can define a structure, and you can come here and use that to simulate an example. For example, a transaction. We can say let tx1 is equal to transactions, and I need to call it transaction, just a single transaction, and I will pass in the transaction that I want to. So I want 500. Okay, that's the amount that I'm sending in this transaction. And this can be very simple for you doing something clean, something simple, something not too complicated. So you just want to use something as this. So transaction, and the user or whomever is receiving this transaction, so you can pass in the recipient public key. So I will say string, and then from, and the owner's public key, and let's give it 0x this. Okay, this is one owner's. We can also perform another transaction again. This transaction 2, and let's say you're sending 300 tokens. So I'm gonna say 0x. Okay, so this is it, and then you can print out that transaction. You can print it out. So I'm gonna put it top here. So we say print line, say transaction 1 is this, and you can see, sorry, let's format this. Okay, so we can say this tx1, another transaction which is tx2. So let's run that and see how it goes. You can see here, this is the first transaction, and this is the second transaction. Okay, you can even format the second one, a little bit by saying transaction 2 and transaction 2 and tokens sent to. Okay, tokens sent to this. So I'm going to put this dot 0 tx2 dot 1. So I'm grabbing those two information like that. This is tuple based, so tuple based structure. All right, and let's run that again to see how it goes. So this is the first one, and you can see the second one, 300 tokens sent to this address. All right, so there's also, let's create another token, like I want to, this is going to be like a nested struct when a structure has another struct inside. Okay, so remember that we had, let me remove this for now or comment it out. I'm just going to implement something similar here. I'll have place to use that properly. So 1. So now let's say we have another structure called struct, called block, for a block in the blockchain, and it has an index, change that. It has a miner, that's a transaction, count count. So each block contains multiple transactions, so that is what it means. So transaction count, and it also has miner. So who mined this block? Okay, the miner is going to be this blockchain user. You getting that? So now I'm using this blockchain user inside another struct, which is, very funny, but that is the idea in a multi-dimensional structure. So at this point, I'm going to add this because I just want to log this out without doing too many fancy stuff about it. So now we need to create a new user. So we're creating a new user where, by saying let block, small shots, block, or let's say let mind block is equal to this block struct, and you want to give index to be 1. That will be like the genesis block, and the miner to be this user 1 that we created. You remember, so this user 1, we can just send it to be the miner, and the transaction count to be 2 transactions for this particular block of code. And yep, so this creates a struct for you, a data type that represents this. So what's the problem here? So it does not implement debug, so this debug is an issue, so I'm going to remove it. And so we have everything in place, so let's log it out. So to log it out, I'm going to use this. So we have the block index, the miner, the transaction, and the active count. So you now see that this block has the index. I'm accessing the miner, and the miner has a username. The miner has quite a lot of things other than a username. It has a username, mine block. Sorry, I'm calling the wrong. So let's do that better. I think I should just call it block. It's a lot simpler, straightforward. So we have block. So you can see this miner has all the ingredients that make for a miner, of a user, including their username, their public key, the functions that it comes with as well, and so a lot of those things. But all we want in this case is just the username, and these are the block count and all of that. So you can display this by running this. You get that. So that is how it is. This block index 1, miner is daltonic, transaction count is 2, active user is not active. Okay, so this is what you should know about struct. This is just it, struct in Rust, and if you know this alone, it's more than enough for you to crush your project. This is enough information. So in the next part of this video, I'm going to teach you about Enum. Okay, so in the next module, let's discuss about Enum. Okay, so let's get to Enum. Let's create a new file. It's going to be module 7. It's called Enum examples.rs. RS, of course, is for Rust. Okay, some of these things I don't need to tell you because you already are into programming, so if you understand what file extension really is. So how do you create an enum? It's quite similar to how you do create a struct as well. So I'm going to do this here, comment this out, say module 7 enum, and replace this here, come here to a public function demo. And okay, so how do you create an enum? You use the keyword enum and you give it a name. Let's call this one, for example, transaction type, So what happened is that Enum allows you to name a set of helps you to define a set of named values. So the values, they range from 0 to infinity, and so you can actually name those values so that you can use them in the course of your application. So let me give you an example. We have this Enum, which is transaction type. We have one called transfer. So when you've made transfer, you have another one called mint, when you've minted a token, burn, when you've burnt a token, and stake, when you stake the token. So these represent, this is the same thing as me writing transfer equal to 0, mint 1. You understand that all this information, they are just 0 to whatever number they are. Okay, so that is what an Enum does under the hood. It helps you to structure or to customize, the some values that you're going to be using, and you don't want to be using zeros and ones and all that. You want to make sure that it is human readable. So that is what Enum does for you. So these are transaction types that we're going to be using across our application. So this is very important when you're coding smart contract and all that. So let's work with it. So let's say TX, which is transaction type, is equal to, we call on that transaction type and access the transfer, the transfer operation. And this is, you see, transfer is equal to 0, so it's the first one. So this is the type of transaction that you're doing. Now let's use the match statement to check, to do some manipulations here. So we'll say transaction type. All right, I want to say this: when this transaction type is equal to, if it is equal to transfer, this is what we want. We want to print that, the token, processing a token transfer. So we want to also check for when it is minting and when it is bound or when it is staked. So these are various match patterns. So we're matching and we're checking. So anyone that matches here will be what will be displayed here. So let's look at it. So I'm going to run this. So you see that is a transfer process. If I do select like bond, let's see what it will run. Say burning token supply. You understand? So that helps us to define status. That helps us to define these things properly. So next, I will show you, there are many ways that I'm going to be using this, Enum, and very creative ways. And I'm going to be showing you, Now let's try an Enum that represents events that happen on a smart contract. So to do that, let's create a new Enum. Call this Enum contract event. Okay, so we're going to need some events such as contract deployed, and we have contract terminated. Okay, this will be like 0, 1, this transfer, token transfer event, and it's going to contain it's going to be a little bit of different customized, so you can actually customize your this thing, your Enum as well. So this one is going to contain some information such as, where is this, from which address the money was coming from and to which one is going, and the amount that was carried out in that transaction, okay, which is U64. Okay, and you also need, this is Oracle update. All right, so the price, which is a floating point. So
these are various enum, and some of them contain some extra information, which is pretty cool. I mean, yeah, that's one of the reasons I like Rust, and a lot of advantage it provides you to manipulate data on a smart contract level. So at this point, let's use that to create a variable. Say let transfer event equal to this contract event, and we're targeting this token transfer, and for this token transfer, I'm gonna need a tool, which is gonna be a string from a wallet address. I'm just gonna grab a wallet address, or just formulate one, 0x blah blah blah. Sorry. Okay, I have another one to this address string. I need to break this into multiple lines, so it will be a lot cleaner. So let me break that. So this is gonna be like, okay, and we need an amount, let's say 500. Okay, so these are the transfer events that it's needed to be created. So then we're going to call on the Oracle event as well. Oracle event. That's how you pass an event. In Solidity there is a concept called event, so this makes it possible. So I'm going to say event, call on that contract event again, and Oracle update. And in this Oracle update, all we need is the price, which we'll give it around 0.56, something as little as that, as simple. Sorry. So this is how you access or you create events. You provide additional information inside an event. You can see how we did that for this transfer token and this Oracle of this. So let us do our matching sequence again. So I'm going to come here, I'll match. I want to match this transfer event, and I want to say if the contract, if it is matching a contract event called contract deployed, should print out, should say print line, say smart contract deployed. However, if it says contract terminated, say contract terminated, and if it says transfer token transfer, sorry, then we're going to do this. We're going to need the from to string. We want to print out those information about the string, and of course you can break this into multiple lines by using a block, and you can say something like transfer, okay, transfer of dash tokens from to okay, so you say amount from and then to, okay, and lastly we can see contract event. We want to call on the oracle. So if it's this oracle, we want to print oracle updated price to, and then you can pass this price here. Okay, so we're going to use that to match this. Let's run that. Okay, or before we run that, let's also do this match for, let's match for this oracle event as well. Okay, I'm gonna come here, oracle event. I will see new price. Just want to say new price from oracle is this, and if there is no new price, if there is no new price, you know, if there is no oracle event, then we just want to print out a statement saying unhandled error, unhandled event. Okay, if there is any other event that is not captured within these matches. Okay, so that's what we're doing. So let's save that and run this. So I'm going to run that now. You can see for this event here, you can see for this transfer event, I actually made a mistake in naming convention. Transfer event. Okay, so you can see transfer of token 500 from this account to that account, and you can see the new price zone as well. So these are some events. This is how you carry out events in Rust. It's a known what's it called? A known concept. Is a very frequent concept that is used during programming, and yeah, so you need to know how to handle this. All right, so that is for handling events. So we also need to create another one. Let me teach you how to handle status. Another use case of Enum is when you want to handle transaction status. Okay, so let's have a transaction status event design. So I'm going to come here and say Enum transaction status. Now we have pending state, we have confirmed state, which carries an extra data, which in this case is a tuple U32, and this is the block number in which the transaction was confirmed. Okay, so let's say that is the block number, and then field, which will carry a string. Okay, so this is us using Enum along with as a tuple, along with tuples. Okay, tuple as a costume data type. You understand? So this one is going to contain error message, reason why it failed. This is just very beautiful, if you ask me. Okay, so let's create a transaction. Let's say tx1 is equal to this transaction status. I want to access the pending state. Okay, I also want to do that again for tx2, and it's going to be the confirmed state, and we need to specify which block number this was confirmed. Let's say 1 2 3 4 5, and we also need the third one, which is the failed state, and we need to say string, or I could just simply say invalid signature Okay, say dot to string. Okay, so invalid signature here, make sure that is a string, and we can display the status. So to display the status, you need to implement a certain behavior, a certain trait for this transaction status. So let's come here and we'll say implement transaction status, and want to give it a function for displaying, the status. Display status, and of course you need to pass the self, that is the object itself or the transaction status that you're trying to format or manipulate. So we call it self right here, and you want to perform a match here. You can basically do anything within this space. Okay, so want to match self if the transaction status is spending, if it is spending, then want to say print line. Okay, so we're basically redefining how we normally presented this transaction information. So we want to say transaction is currently pending. Okay, all right, otherwise want to check if it is confirmed. So if it is confirmed, we're passing in a block. Okay, so we're retrieving that block, a block of code there, and we want to simply say transaction confirmed in block. You put the block number here. Okay, and say block. All right, and lastly, you also want to check for pending, failed, and you want to call this error, and you say transaction failed due to, put the error here. All right, so this now is an implementation. It gives this transaction status a certain function that enables it to properly display this instead of manually doing it this way that we've been doing it. You don't have to do it here. We can invoke this display function and it will present that information. So long as that transaction status has been created, we can invoke this display function now. So for example, you can see here we've created this transaction status. This one creation, this another creation, and this is another creation. So let's make use of that. So if I say tx1 dot display, tx1 dot display status, I want to do that for tx2 and 3. Okay, so let's check that out and see how it goes. So if I run this, you can see that the transaction status is currently pending for this one here due to how we had described it to behave here with this implementation function. You can see this one here that says transaction confirmed in block 1, 2, 3, 4, 5, and also this one that says transaction failed due to invalid signature. Okay, due to invalid signature, and we can due to invalid signature is the error that is being passed in there. So that's a lot of cool stuff to do. Okay, so let's create another Enum. I'm just showing you different use cases of Enum, which is which is quite beautiful. Okay, and I like the fact that all these concepts are very closely
mirrored or narrowed to concept that you will encounter building smart contract or writing blockchain based core application or whatever. Okay, so let's work on another event or enum that can represent events that has to do with the contract life cycle. So life cycle are different stages which can be used in monitoring the status of the blockchain. So for the status of a smart contract, for example, when a smart contract has been deployed, so that is a life cycle stage, or when it is being initialized, that is a stage, a life cycle, and so on, various things that could happen when it is paused, when it's terminated. So let's call this contract life cycle. In this contract life cycle, we need the initialization. This is a stage. We need the active stage, and this active stage is going to also is a structure. Basically, is a struct that has a participant of unsigned integer. So you'll be able to know how many participants that are in this life cycle. Okay, and we need a post state. This is another life cycle, and terminated. This also a life cycle. So we want to implement some certain features, with inside this. Want to give this life cycle a certain functionality. Okay, so to do that, we're going to have to implement that again, for contract life cycle, and want to give it a function called fn called display state. Okay, and of course you need to pass in that self here, and you want to consult the match sequence. So want to match self, want to check on it, want to say if contract lifecycle is initialization, then it should print out smart contract is being initialized. Okay, so this should be the message. What if it is active? So we need to, if it is active, then want to print out this statement, contract is active. We can break it into another line. So we can say contract is active with a number of participants, and you can pass in the participant number here. So, and lastly, not lastly, you want to check on the post state. You can say contract is currently paused, and lastly you want the termination phase, terminated. So contract has been terminated. Okay, so these are various. This is what it would take to display information, regarding the status of this life cycle. So at this point, you can come here and say, we can just copy something like this. Okay, I'm going to call this contract. Okay, so say contract life cycle, and we are looking for the
active state, and this active state, of course, is not a tuple, but so it's not a tuple, so it's a struct. Basically, it's a struct like, data type that provides you an extra field, that you can supply some information. So in this case, we want to supply the participants. Okay, number of participants is going to be 100. All right, in this phase, and you want to also say post contract, and you're looking for post, and this post basically doesn't require an extra field. And lastly, terminated, call on this. So these are various cases. So let's call on that display function to see the difference. So we can say contract dot display state. We can call on this post contract dot display state, and we can call on terminated contract dot display state. So these are various. This gives you a rich, collection of examples of how you can, utilize struct and what's it called, enum, and actually implement certain function to an enum. You see, enum and struct are quite similar in operations. You can see how I implemented certain features to an enum, and also with the struct as well. So struct data type and enum data type, they utilize, you can both give them an implementation to extend their functionality or to make them a lot much better. So I'm going to test it out. So you can see contract post contract is active with 1000 participants and contract terminated. So that is what it is, with enum. So in the next part of this code, I'm going to take you into options. Okay, we'll tell you what options are and how they can be used, for effective matching. Okay, so let's jump into module 8. All right, so create this new file. It's all about option. Okay, come here. So close this and create a public function or demo, and make sure that you import it here. All right, so here we go. So now let's take care of option. So what is an option? Option in Rust is very close to being an enum. So basically, I would say is an enum that has two value-based system. So an option can either be a sum, can result in a sum, or result in a none. Sum, that means it has a value. None, that means it doesn't have any value. Okay, and they are all designed to increase the accuracy of matching or finding out, matching a condition. Okay, so it's best described when you see it, in code. So let me do that for you. So now let's write this code. These are example. So option basics example. So these are the basic things about an option. So let's say we have a variable called sum balance, and this sum balance is equal to sum, and the value of this sum is 1000. So now to describe the type of this is going to be called option is the type, and is holding, let's give it an unsigned integer 64 instead. So that is what the size of this variable. Okay,
this would be like the token balance of the user. All right, so we can just call it, let's call it something like user address balance, and we have another one called user address, and this one is going to be a string slice str, and this should be the address of the user. So we're going to say something like x a b c 1 2 3. Okay, so this is the address of this user, and let's say this is a condition when there is no value at all, no value, and it's going to be an option still, and u64, I want to call it none. Okay, so remember what I said, an option can either be a sum or can be a none. So that is just an example. So this example will be very useful when there is no balance, there is no user balance. Okay, no user balance found. Okay, so we can use that to display, to do some proper matching. So let's perform a match. Okay, and to perform that match, we want to say match as usual, user balance, and want to say sum, sum balance, and this would be the value balance that we want to check on. If it has a value, if there is a sum has this value, that means it contains something like 1000. Okay, then it should do this print line. It should say user has a balance of dash tokens, and then we want to put the balance here. Otherwise, if there is no balance, you see how straightforward this is. If there is no balance, it should just print print line, say no balance found for this user, for this account. Okay, so let's check it out. Let's just also match for address. You see, there is two options here: a sum and a none. Two menu items. Okay, so this one we're checking for user address, and this time want to check on address. Say found address. Want to say found blockchain address, and we can do this, call this address. Otherwise, you can say no address found, address found. Okay, so there we go, and we can execute this to see. You can see that situation. User has a balance of this, and we've been able to find this thing. What if I pass in this no value in this situation? For example, here. Okay, instead of when it doesn't have a balance, this is when there is a balance, and this is when there is no balance. So I'm going to pass, I'll call it no balance. I think no balance. It's a lot explainable. So I'm going to pass no balance. Let's run that and see. Okay, so basically I kind of missed that, but it's actually showing here that no balance found for this account. Okay, so you see that the second option of none is what is being displayed. If I change it, swap it back to an account that is found, and run that, you find out that user balance has been found. So that is
this condition, you can use that to use an option and option which has sum and none to match records more effectively. You're going to see a lot about this sum and none in a lot when you're building with Rust. So let's go into the next example. So the next example is using if-let example. So come here. So we've used if-let example before, but let's demonstrate it using this sum. So we're saying let let's say some balance equal to, say, sum 1000. So I'm gonna make sure that this is unsigned integer 64. Okay, so we can even call this user balance. Okay, so let's say this is a user balance. All right, so we can use if-let here, if-let sum. So you see where it's important. So if there is a content, okay, then this block of code is going to run. I'm going to call this balance. We're testing it against this user balance. All right, so if there is a user balance, okay, then this line of code is going to run, and it's simply going to say using if-let user has a balance of this token, okay, else is another condition. Okay, so if you're using if-let, then if condition, basically you're using if condition. You remember the last one we have this this non method, and it kind of goes where when you're using it with a match sequence, but this one is just an if condition, if else condition. So if there is a match for a user balance, you should display this. Otherwise you just say no balance found for this user, for the user. All right, so that is how you can use it along with if-let sum. So remember, if-let is very important to check for the existence of a certain value. Then if that value exists, then you should execute it. Otherwise, you should just keep moving without. It's very good for handling error situation. Situation that could have resulted in error, you can prevent that by using an if-let. Okay, so that's why it's important. Now let's run that. Let's see. Run this. You can see using if-let user has a balance of this token. Great. So sum, there is this idea of unwrap in sum, and unwrap basically is to extract the value that is inside that sum. Okay, so but there is a problem with it. It panics when there is if it is a none. You understand that? So you have to be careful with that. So let's try this unwrap example. Let's say let user balance. I'm going to just copy this because I don't want to duplicate this over. Maybe writing this myself. So this is user balance. I want to say let the balance be equal to sum user balance dot unwrap. Okay, so this unwrap method, you can see what it's saying, returns the contained sum value. So the value of the sum consuming self value. So because this function may panic, its use is generally discouraged. Instead, prefer to use pattern matching and handle
the non case explicitly, or call unwrap or unwrap or s or unwrap or default. So these are some basic ways of using this. I like the way these extra context, give you very fantastic examples on how to use this. So it is discouraged because if there is no value here, then it will result in a problem. So basically, you're going to use this unwrap, only this unwrap situation like this for a situation when you are absolutely sure that this sum is always going to have a value. Okay. So now you can print this print line and say unwrapped balance of, let's say, balance. Okay, so let's also look at this. So let's try the first example, this unwrap. So you can see user balance, is 1000. It was extracted. What about if I'm using no balance here? If I'm unwrapping a no balance because it doesn't have any value, let's check it out. Run. You can see it resulted in a panic. See, called unwrap on non-value, run with rust backtrace, blah blah blah. So this is clearly telling you that you should not use that value. Okay, I shouldn't try that. That is not, safe. Okay, so that is how you deal with unwrap. What about, there is also the concept of unwrap or. Remember, in this place we're told that we can use unwrap or, instead, so that in case there is no value, you can always resort to a default. There's also other variants of it here. So let's check it out. So see. So this is unwrap or example, and we still have that user balance, or we can use the one that has no balance. Okay, so we can say no balance and call this no balance. Then we can call on unwrap or and give it a default value of 0. If there is no value in this, then it should give it a default of 0. And then we can say no balance found. So using a default, okay, and the default tokens. Yep. So let's run this and see this live. Okay, let's execute that. You can see no balance found, so using a default value of 0 token. This is pretty fantastic. So that is a beautiful use case of unwrapping a sum. Okay, you unwrap and also make sure that you provide security. I will recommend that this will be the best way if you're going to be using this particular use case, or you use a matching sequence, which is much safer for you. That is what I would recommend as well. So there's also called a map example. Okay, concept of mapping. So let me show you that. Let's say we have a sum, a fee, and copy this line of code. So let's say this is some fee that you need to pay, and let's say it's only 10 tokens of whatever that is, and you want to call on this let result equal to
this sum fee, you call on a map. A map requires a function, but then you can utilize a closure. Okay, so I'm going to pass in a closure, which is basically an inline function, and this is the fee. And I want to multiply this fee by 2. All right, so this will double the fee of, it will double the fee of the transaction fee. Okay, that is what we simply did here. And we can print out that result. Say print line, say doubled transaction fee. Okay, and you know how it goes. You want to format this very well, because what you are getting is an option, it's not a pure value. So I think I can just even make it a lot prettier by adding that. So, and we'll say result. Okay, so unlike this here, you're getting a pure unsigned integer, a primitive data type, but here you're not getting a primitive data type. This is an option. Okay, so and yeah, we can then make sure that we are logging this out. Okay, let's run this. Okay, you can see some, no, and I think let me remove this and see if it's a lot better. You see that sum and it's 20, so I basically doubled the value of that sum. Pretty cool. So you can use mapping to do some inline manipulation of the value of a sum. Okay, so basically those are the most important things that you can do with the most basic things that you can do, mostly what you need to do with an option. You understand? We've dealt with situation of option of sum and none. Okay, matching sum and none. We've had if let situation, if let sum situation. We have the unwrap, we have the unwrap or, we have the map example, and these are various ways which you can richly use the sum concept in Rust. So you create a new file here. Okay, and in this new file, you know how it goes, the drill. So it's a public function, just setting up everything, demo, and close this. Module 9, which is talking about results. Okay, so here we are. So we have another public function. Well, let's call this one result basics. So we want to talk about the result basics of basics, So please know that result and options, they are just quite similar. You understand? They serve for the same thing. So for example, sum, can either be, option and result are basically the same thing. They have the same characteristics. Okay, maybe not down to the core, but in its general sense. So an option can either be a sum or a none. Meanwhile, a result can either be an okay or an error. So that is what you should know, the difference between a sum and an option and a result. So let's check this basic out. So let's have, say, let success transaction is equal to, okay, and this okay, we're passing in 200 inside. So what we're doing here is we're saying that we're passing unsigned integer 64 is what this is going to be, and a string that it should return So let me state it again. There's just some few differences between an option and a result. Option you can define for when it have a value, which is some, and when it doesn't have a value, which is none. But in result, you define that, okay and error situation by specifying if it is okay, this is the data type that you should return, which is an integer in this case. But if it's failed, it should return a string, which is the error situation. Okay, so it should return a string as a report of why it failed. So that is why we have this definition of a result. You understand that? So we also have failed situation. So it's basically the same thing, but this time we are passing in error. So if it's an error, we're defining an error. So transaction failed with error, and then you pass in that error. So you have to do that. I made a mistake here. So have E for error, and you have, I'm sorry, not that. So you don't need to print it here. This is not a place for printing. So we just need to state the error here. Say transaction failed due to insufficient funds. So these is mostly used, these result and options are often used to, that they are both types of enum. Okay, they are still enumerables, and especially this result is used to determine or to give a detailed report of an outcome. Okay, meanwhile the other one is used to mostly test out a value, you understand, of an operation. So that is the difference. And you come here, we always have to perform match, so in successful transaction, if the transaction is okay with an amount, that means it does have an amount, okay, like this 200 that we specified here, then it should print out that it should say transaction succeeded with that specific amount. Otherwise, if there is an error to it, it should capture that error and transmit it saying transaction failed with that specific error, like you can see here. So this is how you perform that. If I bring up this, you find out that they are pretty much the same. You can see the situation. You can see that the only difference is that you can customize your none or your invalid error state, and you must also have value for result when it is okay. So it's basically just about the same thing, but this is naturally being used for detecting outcomes. You understand that? So let's also do for failed transaction. So if there is an amount, you want to say transaction succeeded with that, but if there is no amount, you should also say this failed. Okay, so let's run this first. So I'm going to run that to see. In the case of a successful transaction, which is this, it does have some value, which is okay. It has an amount, so it's going to print out this result, as you can see here. Okay, but in this case, you find out that what the result is an error. So this will not match, and this is the one that matches, and it's going to print out this error saying transaction failed with error, and you have this the definition of that error, which is what we stated here. So this is how the basics of result works.
let's try it with Unwrap. Remember, we did do Unwrap in the previous one. So let's unwrap the value. You can unwrap the value of a result just like you can unwrap with the value of an option. All right, so I'm gonna come here, and let's say we have that failed transaction. So here's a failed transaction, and it's just saying it's an error that states transaction failed. Okay, so let's say the amount or default. So say failed transaction, and you're calling this unwrap all. Okay, so the default is going to be 0 in this case. So we are unwrapping, if it does have a value, but it clearly doesn't have a value, it has an error. So we have to say print line. Okay, so I'll say the first thing I want to say transaction failed, defaulting to tokens. All right, and then you can pass in the amount or default value there. So let's check it out, run that. So you can see transaction failed, defaulting to 0 tokens. All right, because there was no value here. What we had here is an error. Okay, so that is what it is. Okay, and that is how you can use unwrap all with a result. All right, what about map error? So there's another feature as well called map error. I'm gonna show you that. Okay, so here we have an error situation. We can say failed transaction, but it has a different message. We can say insufficient, gas fee. So insufficient gas fee here. So we can say let this transformed. So this mapping is often used for transforming a data because you want to perform a callback function, which is basically a closure inside of that operation before returning the value. So you want to say transformed error is equal to this failed transaction, okay, dot map error, and you can see what it's saying here. I'm gonna remove it there because it's probably blocking my face. So what it's simply saying is map through this by applying a function contained in the error value. So we're going to apply a function, and in this case, the best thing you want to do is to apply a closure. So here we are. I'm going to apply this function to this error. So the error is what we want. We want to format it properly. So call on this format, and I'll say blockchain chain error, and you pass in that error. It's just generally like a print out, but instead of this returning, how about let's just see it in action. So okay, so I'm gonna come to the next line and say print line this error. So transformed error is this. So I'm gonna pass in that transformed error. So let's see how it goes, and copy this line. You run that, you can see transformed error is blockchain. So you have blockchain error, insufficient gas fee. So here we are. The main error is contained here, but we just added, we just transformed and made it a lot more, cleaner. You understand? We just modified this error. That's just all we did. We modified the error to make it look more, beautiful. So that is another way you can manipulate the error that comes as a result, from a result, value. Okay. So that will be it for all you need to know about, result and how you can use them, that type of result. So now let's actually use combine result and option. You can actually do that, combine result and option. So we're going to do that in the next module. So I'm going to come here. Let's create a new file, call it module 10. So this is option result combination. Option result combination. So module 10. And let's create that function here. Public function fn demo. Okay, so let's check out the basics. Okay, so let's get it done. This one is not going to be it's not going to require so many functionalities. So let me show you an example. So let's call this successful transactions. Let me show you how you can use you can combine what's it called, options and results. So I'm going to have, this is an option. So I want to have, okay, this is I want to have a result. So this is a result here called, it said transaction successful. Okay, so this is a status, and if you check out this, if you check it out, it's going to be a string to a string. So but I want to wrap it upon an option. So I'm going to say sum and pass this here. Okay, so that will now become an option. Okay, so I'm going to wrap this around an option, because right now if I say save it, it will produce an error. So if I wrap this around an option, okay, this will work just fine. So I'm basically wrapping, putting a result inside an option. Okay, so I'm going to do something the same for failed transaction as well. So this is failed transaction, and it has an error code. This is going to be an error this time around. So let's change the content. This is an error. So we have transaction failed due to insufficient fund, right? So these are two conditions, and I want to get another condition that literally doesn't have it is none. You understand? So let's create that from scratch. We have let no transaction equal to none. Now none is an option, okay, right? But we also want to make it a result. So I'm going to copy the content of this, paste it here. So this is a result. So this is how you have combined options and results together. So let's do some matching to see how it goes. So I'm going to match for successful add transactions. Okay, so I'm spelling this correct. Transactions.
Okay, so I think that's much better. So successful transaction, I'm gonna say sum. Now you have to combine it. You don't just say sum and passing this successful passing a message. You understand? It doesn't just work like that because it requires a result to be inside. So I would say okay, which is a result. So if it results in an okay situation and the message that it was passed, then I want it to pass to print something out. So print line and say success. Okay, and want to just display the result, which is the message. Okay, you can end it with that. So we need to also check for error, and error. You also have the message and you have error. Okay, so then you also want to check for a non situation, and you don't need anything here, so you can just say no transaction result available. Okay, so you have this here. So this is how you combine it, and if I run this, find out that is a successful transaction because there is an option that has a result inside. You can see how we use that to match this. So there are some useful use case in this arrangement. So let's also duplicate that for failed transaction, and if it is failed transaction, this should print out the second message, which is an error. So let's run that. You can see error, transaction failed due to insufficient fund. And let's also run that for the third message, which is a no transaction. So let's run that. You understand? Because why this is passing? Because there is an option for checking a no transaction, a non-transaction or zero transaction. So let's run that. You can see that no transaction result available. Okay, that is pretty straightforward. So that is how you can combine options and result together. That is just one example, and I'm sure that as you dive deep into Rust, you find various use cases where you have to use this. Okay, so with your little research can really brush this up. Okay, so I'll see you in the next part of this video. Okay, so let's talk about trait. Okay, so this is the module 11. We're just one module short of completing this course. Okay, so let's second to the last module. Let's work on this. Okay, so trait. What are traits? Let me set up this public function. Okay, so make sure. So what are traits? Traits in Rust are codes that gives a structure or an enumerable more information, gives it more attributes and more features, more behaviors. You understand? We've been doing this already when we worked on enums and struct. We did that in a subtle way, but now I'm gonna even dive in and describe it more. So there's a full concept called traits. Okay, so let's work on this. So let's say we have a public struct named account, and let us create a value within here for this account. Okay, this account has some information such as username, username, it's going to be string, and balance.
going to be on the U64. Okay, so I have this, I'm creating this. This is the username Alice, and the balance is 5,000 tokens. Okay, so this is from this account. I want to give it some traits. Okay, I want to give this account some trait to make it describe some certain stuffs for us. Okay, so just follow me here. So how do you define a trait? Okay, let's say this particular one called trait is called describable. It adds some description, so it just makes the account struct more describable. I'm going to get to that. So let's create a function called describe. You notice the way it's almost similar to how we work on implementation. So describe this self, okay, and it's going to return a string. Okay, so it's going to take a reference of self, borrowed self, okay, because it's not going to be modifying anything. It's just going to make some modification on how we display information about this account. So at this point, we can then describe more information about this account by saying implement describable. Okay, so we're implementing this describable for account. Okay, this is quite different from how we've worked with struct. If you look at struct, we have a struct and we just implement a certain feature for it. But this time around with trait, you actually are implementing, you're giving this is principle of inheritance. Basically, you are giving this account this behavior, this describable behavior. Okay, you're just granting it to this account. Now you're feeding it in, and it's not part of this account system. All right, so and you can modify this function even inside of here. So this account has inherited this describable, which is here. So within here, I can modify how this behaves. Okay, now I just added only a generic function, but now I can modify it to behave better than what it normally would have done. So I will say describe. Okay, so I want to format something, the string, that comes in here. So I want to format account. Okay, so the string that is going to be returned is going to be a format of the string account and then balance. Okay, and what is account is self dot username and self dot balance. Okay, so these are the details that this particular describable, when it comes to account, this is how it's going to behave. But any other thing that is inheriting this describable is not going to have this full behavior here. So I'm going to also create another one. Let's say we got transactions here. Okay, this is transaction, and it just has ID, amount, sender, and receiver. Okay, and want to also implement some things for this transaction. Okay, want to modify this describable trait as well. You can see how these various traits, they are sharing this one trait. These various structs are sharing this one trait. This is the concept or principle of trait. Okay, is when one behavior or attributes are shared across multiple structures or enums, you understand, to enhance their behavior, and all that. So in this account place, I'm going to modify here a little bit. It's going to now be transaction. transaction ID. This is the amount, say tokens, and say from this address and say to this address here. Okay, and okay, so it will be self.id, self.amount, self.from, which is the sender, and self. To, which is the receiver. Okay, so this is how this is formatted. Okay, so we want to create another function that will help us to describe information about transaction and account. Okay, so this one function will be able to describe information about this account and describe information about this transaction without having to change anything about it. So we're just showing you how to use a shared trait here. So the name of the function is going to be called print describable. So public function called print describable. So now let's give it some instruction. So if a function is going to be dealing with traits, it's going to receive a trait as an input, then you have to put this here. This is a type. Okay, so type is trait for T. If it's a function, it will be F, but T, and the name of the trait is called describable. Okay, and then you can pass in the item. You understand that you want to send here. Okay, or you can call it trait item. So the trait item is going to be a reference to that trait. Okay, so now we just simply print line and say description, and you do item, trait item dot describe, this describe function. So this describe function will handle whatever trait, so long as those traits are inheriting describe function, it will trigger their describe function and they're going to render what it's supposed to display. So for example, let's come here now. Let's also create a dummy, create a transaction. So we're just adding transaction information here, just like we did before here. Now let's call print description, invoke that function, and then we'll do for account. Okay, but you know that it has to be a reference of it and not because of the principle of ownership and borrow, so you have to pass in this because you're referring to it. You don't want to, you're not the owner of it. You understand that? So this function is not the owner of it, so you have to pass it in as a reference. All right, and you also want to pass this as a reference as well. Okay, so these two items, let's print those two out and see how it goes. So you can see that this description printed out Alice account details for and also the transaction details here as well. This is cool. You have one function printing displaying information about two different structures that inherited the same trait. So you're calling the same trait, the function of the same trait, which is this, that they both have and they are a little bit wired differently, formatted differently, and when you call that function, it just execute it and display it just beautifully. So this is the essence of trait. So in essence, trait is very important. It's very useful for defining contract behavior or asset description. So if you have some assets, NFTs or something, and you want to give them similar traits and all of that, this will be very useful in that kind of situation. And also their behavior as well. So this is one fantastic feature that Rust does have, over, stuff like Solidity. So let's give it another trait. Okay, let's give them another trait called summarizable. You understand? Let's give it another feature called summarizable, and let's define that trait. So come here, call this summarizable. This is another trait. And what does this summarizable do? It's going to be a function that is called summary. Okay, and of course it's going to take self, okay, and return a string. Okay, what is it going to do? The return string will be this string from, you say here, further details hidden. Okay, so further details hidden, and this is the default function for default behavior for the summary function. But then we also want to implement it for account and transaction. So let's do that. So this is an example of a place that I've implemented for account. I'm going to copy this line of code and come here and say summarizable instead, and say that, of course, we don't have username. So you say user, balance. You can say add tokens here. Okay, and then you say self dot username and self dot balance. Sorry, we don't have this function here. We have to use summary. So I'm going to bring in summary here. So we're inheriting it and we're modifying the behavior of this function here. So this function in here is going to now carry this behavior. This is the string that is going to return instead of this default one. Okay, and then want to do the same for these transactions. So I want to implement for transaction, implement summarizable for transaction, but we're not going to do anything to it. We're just going to leave it as default. So it's going to carry this default thing in total. So now let's come here and display those information. So we have print 9, and we say account summary. Okay, and put this account here, which is this detail here. Okay, dot, it has describe, and it has a summary as well, which is this here, which is based on summarizable trait. Okay, so if we hover here, you see the definition of that function. Okay, so and you want to also do the same for transaction summary, and you want to say transaction.summary. So you save those two and execute it on the terminal, run. You can see that this one has, this is the summary of it. You can see how we described it here for user balance tokens. You can see user is Alice, balance is what, 5,000 tokens. But for the second one that only inherited the default behavior, you understand, the hidden details, it just described only, it just summarized and dropped only the hidden details. So this is the principle of inheritance in Rust. I think it's just pretty straightforward, simple, and all that. I like it. It's pretty cool. And let's also work on multiple traits. Example, multiple trait example. So this is another function almost similar to this one that I'm going to do. This helps you to print one trait, but let's see how we can print multiple traits. So this is a multiple trait example, and of course, if a function is going to be dealing with a trait, actually multiple trait, you want to say item, or trait item is, you say implement describable. Okay, and sorry, not that. I'm wrong. So let me come back here. I'll be back. So, and if a function is dealing with trait, just like with this one here, you have to put in that information, say trait, and then you say describable. That is one of the traits that this function is going to deal with, and then use this plus sign to say summarizable. So it's going to have access to these two traits, and then the item is going to be based on a reference of traits, just like with the other one before. You can print out full description, full description, and the full description is going to be this item, trait item dot describe. Okay, you have another one here. This one is summary. This summary is going to be summarize or summary here. So this one function have access to this, and we can then invoke it here. So come here and say multiple trait example, and I will pass it for this account. I'll also pass it for this transaction. Okay, so let's run that and see. So we have full description here. We have summary here for this full description for account and summary for account. I have full description for transaction and summary for transaction. So what happens if I didn't implement summarizable for transaction? Then this is not going to be, you can't pass it in. You understand? So whatever trait that you're passing in, whatever struct that you're passing in should have the traits that are the same trait as the ones that can pass through into this multiple trait example. Okay, and lastly, want to look at a different way of also implementing traits. Okay, so let's look at it. So this function is going to behave a little bit different than the other ones. So in these other ones, this is how you implement trait, and then you glue it using this multi-trait. You join it with another function. Or if you want to do it all at once, okay, let me show you this. So this implements a trait example. So we have an example of a trait item here. This trait item is going to implement describable. You see how we do it here, and we just want to print out saying implement traits description, and then you say trait item dot describable. So this is another way of doing it, that is different from this. This is one way of doing it, okay, and this is another way of doing exactly the same thing. So we can call this now. We can come here, and in this one you don't need to pass it as a reference. You can just pass it as as it is. So you can say implement trait, and you pass account, straightforward, and when you do, you run that, and you can see that it's just implement trait and it still displays the example just fine. All right, so that is all we need to know for now concerning traits. Traits is basically you having shared values or shared characteristics between different structures or enums, and it carries the principles of inheritance, so you can give a struct or two struct as many struct the same trait straight exhibit the behaviors that is a struct or an enum is going to carry. You understand that? So those are the various things you need to know about trait for now. All right, so in the next part, which is the last part of this course, we are going to discuss about concurrency in Rust. Okay, so let's create this last one, and it's called Module 12 concurrency. And what is concurrency talking about? I'm going to do that for you in a moment. FN demo. So here we go. So what does it mean by concurrency? It's the ability to run multiple batch of codes, multiple operations together simultaneously without breaking or waiting for one to finish operating. You understand? It's just running like multiple threads of applications. You understand? Not multiple threads of operations. So it's more like, let me give you a visual example. If you've seen a racetrack where a lot of people are running together and each team, they are handing over the baton to another. So that racetrack is divided into multiple rows, multiple tracks, and each team has to run on that, and Team A does not obstruct Team B from operating, and neither will Team C obstruct Team D from running. So all of them can run at the same time. So that is the idea of concurrency in Rust. We want to show you how you can implement some certain operations that run simultaneously with each other without anyone blocking the other from being fulfilled. You understand? So based on the time gap that it takes to fulfill one, that is how long that particular operation is going to take, and it will not obstruct faster ones from completing earlier. So let's see this in action. Okay, so I'm going to call this one basic thread example. Concurrency is basically threads. In Rust is thread that takes care of this. And let's call this one a handler. Let's key a handler, a handle, and a handle is a thread, and it's coming from this thread standard library. So we have to import it here. So thread here, and if you want to do concurrency, you have to consult this guy called thread. So, and then you have to call on this spawn, which spawn is basically creating a new thread. So we're using this to create a new thread, and that new thread we have to use a function, and the function we want to use is basically a closure. All right, a closure that doesn't have any parameter. Okay, so you can see that the interface or the type of this is actually called thread.handle. So you don't need to put it the compiler by default knows what it is, but this is just showing you the default value it is. Okay, so what happens inside here? So we want to use a for loop. Okay, and want to print out 1 to 4. Let's say 1 to 6, 1 to 5. Okay, so, and you want to say print, you want to say blockchain. Let's write here print line. So this is a new thread. Say blockchain node thread. says, and then you print out the value here, okay, and you want this thread to go to sleep a little bit, to just delay for around 500 milliseconds. So I'll call on this thread dot sleep. There is a sleep method which puts the current thread to sleep for at least a specific amount of time. So we're gonna say sleep, and the duration, for at least a specific amount of time. Duration is normally in milliseconds. Okay, so we say 500. Okay, so it's gonna go to sleep, wait for 500 milliseconds before it counts. It runs this again. Okay, so that's what happens there. So that is one thread, and then this here is another operation. Okay, so it's almost similar to this. I'm going to copy this line, paste it here, and say main blockchain operation. Now this one is not in a thread, so main blockchain operation. Okay, and this one is in a thread right here. This one is a main blockchain operation, and the main blockchain is actually still a thread. If you think about it, it's still a thread by default. Okay, so because it's running on a track as well, and we want to put it to sleep. Okay, so you can put it to sleep still using the same way that we've done before, but I want to show you a different way of implementing this. You can say duration. Okay, want to grab duration from time. You see this, use duration from standard library time. So I'm actually introducing you to a whole lot of a couple of Rust default library. These ones, you don't need to install them. They come default with with the Rust compiler. All right, so this duration, and then you call on this method called from millis, which is from milliseconds. Okay, and then you specify the milliseconds. It's going to be 500 still, so it's going to sleep for 500 milliseconds. So it's exactly the same thing as this. So I don't know, this is wrongly imported. See, use st. So this is how it's supposed to be. Oh, basically I was wrong. This is how it's supposed to be. Sorry. This is not a different way. This one way. I made a mistake. So yeah. So this duration library helps you to convert this, into milliseconds, which is what we put in here in this sleep command, and when I have that. So now apparently this handle right here, is join handle. So I will call on this function called join. So this join actually waits for this particular, it's more like what you use in executing a thread. So you wait for this thread to complete. Okay, so call that join, and I'll call on unwrap. So this unwrap returns okay value, so it's used to ensure that this operation is actually completed. Okay, so without escaping. So that is why we use unwrap, to make sure that this thing is completed. Okay, the operation. So at this point we can then use this. So while you're having one operation going here, you can also have another operation. This is the main, this is the the sub. Okay, so let's watch this, run that. You can see the way they are operating. So the main one is the one to fire. So this runs first, the main thread. Why it ran, this one is also running. I can see that simultaneously this one is running. So let's say we manipulate this a little bit, and we give it 1000. Okay, and we give this 3. Let's see it in action. Run that. So the trade runs 2 times. Basically, this is 2 times 1 to 2. So 2 operations. So if I say 1 to 4 and this one to 7. Okay, so let's see how it works. Okay, so you see that this main operation, this main blockchain trade is running at and waiting only 500. I think we should just make them equal so that we can see the difference in time. We can appreciate it better. Let's run that again. Okay, so the main one runs first, which is this. Okay, before this handle, this execution, and then this is executed, the blockchain trade, the trade runs the first time, and then this main one runs, and this has to wait for runs, and this waited for like 1000 milliseconds before it ran again. So if I say 1005 and let's watch that again, the wait hour, so basically the main blockchain operations completed even before this one started running. What if I swap this and decide to make this like this? Let's watch that. Run that. The trade completes while the main blockchain is still in operation. So this is how the basics of trade, running multiple operations simultaneously in Rust. There's also a trade with move command. Move command is basically there for ownership transfer. So if you want to transfer ownership, remember how important it is for variables to be owned properly, and when you're addressing or referencing it, let it be properly referenced, and not duplicating variables here and there. So that is one of the reasons to enhance memory management in Rust. So let's say we have a vector called block data. So this block data vector, so this is block 1, block 2, block 3, block 4, block 5. Okay, and I want to create this handle function again. I'm going to copy it, paste it here. I'm going to remove all this, or just keep only this. We don't need a for loop. Okay, so do you see this block data? If I'm to use this block data inside here to print it out here, then I must move the ownership of it inside here. That is what is happening. So if I put it here, you see that it will complain because this is inside of a function, and the function is actually a closure. If you're going to move the ownership from this into that closure to make sure that closure has access, an ability to work on this variable, then you have to put that move command. So this is what we have, move command. And secondly, this is a vector. You can't print it out this way, so you have to print it out properly this way. Okay, that is why it was giving it an issue. So you can say here, change the name, say node processed block data. So this block data have been processed. Okay, so and then you can perform this procedure again, which is to unwrap and execute basically. Okay, so this is how you move. It's a thread with move, so you use that to transfer ownership and make sure that variables are properly referenced and with the right with the right access to that data. Okay, so let us execute this. Okay, save that, run that operation. You can see that everything is working. So that simple example is very important, especially as you keep building on with Rust. So you need to be acquainted to this thing, principle of ownership and borrowing. Very important. All right, so there's another example here which has to do with asynchronous request, asynchronous functions. Okay, so which is another thing about threads. Okay, so let's create an asynchronous operation. Okay, so here is a function. I'm not going to give it a public function, it's just going to be a private function. Okay, and we want to give it some information, such as want it to print blockchain async operation started, and we want it to wait for about 2 seconds, and you can achieve this by calling another function called sleep. Okay, it's coming from this particular library. So in this sleep, you need to pass in the duration. Now, to pass in duration, let's use our first let's use a library that is not by default owned by Rust. Okay, a third-party library is called Tuple, and it's used for time management. Okay, so we're going to say Tuple time, use Tuple time, and what you want is this sleep and duration as Tuple duration. Right now, failed to resolve undeclared create, so mod for listen. So we don't yet have it here, except we import, it gets imported. So as of now, it's not actually imported. So let's install this Tuple. Let's have it added. So you can see cargo add, and then the name of this create. It's actually called create, but it's a package. That's what it is. And then you click add, and it's going to add this. And once that is successful, it should be listed here as well. You can see that, so this is you added that to your create. And this time, if I unhook this, you can see, but for this particular operation, we want to update this. We want to use a certain version of this Tuple, which is this version here. I'm going to save this, and you can see how cargo is checking and is updating this back. Okay, so this has been updated for me, and if I do this now, I can access the time feature, which is not available in the new one, or they changed how they used to reference them. Okay, so I'm going to also access sleep feature. I want to access duration feature as Tuple duration. Okay, so you can see I have access to all those, and so at this point I can then do sleep. You can see that Tuple duration, and I want to access this method called from seconds. So how many seconds? I want it to wait for 2 seconds. Now this is an asynchronous function. This sleep function is an asynchronous one called await. Now this await is not going to work because a synchronous function must have the keyword async in front of them. So you can see how that got resolved, and you can then duplicate this and say blockchain operation completed. Okay, so this is an asynchronous function. Please pay attention to that. It's quite different in its operation. So we're going to call it here. I want to call this asynchronous function here by saying synchronous function, and then say, because this has an async in front of it, I'll call await. Yep, and that will be executed. At this point, let us call that basic async function. So I'm going to duplicate this and let us call this function. Okay, but it has to be awaited, it has to be waited for .await, but that will have an issue except you add a sync operation here, sync. Okay, this is okay, but then again I need to make sure that this has yeah, and let's run it. Let's execute that and see. Let's execute this. Cargo run, please. You run that. So it's compiling again all together, and so nothing happened here. So why this isn't working out, is for this reason. I'm going to comment this out for a moment. Okay, try running this again, even without this async feature here. Okay, try running that again. It seems nothing is working. That is because we have made this demo function an asynchronous function. So now I have to call it with this keyword of await. Now if I call that, it's going to give an error because this is not an asynchronous function yet. So we have to make it asynchronous. All right, so I think we can say async here. Okay, now there's another issue. This have to come before it, sorry. Okay, so there's another issue here. Main function is not allowed to be async, so, but you can instruct it that is using this Tokyo main, and that error is going to actually disappear, and then you can call this function successfully without any hassle anymore. So let's run that. You can see blockchain operation started, and then it waited before it got completed. So we can even improve it by say retrying 2 seconds spent. Okay, and before it completes. So let's run that again and see how it goes. So you have this blockchain operation started, you say 2 seconds spent, and then you say completed. That is very cool. So that kind of that is a cool way of doing an asynchronous operation, and that is also based on concurrency as well. Okay, so you can have multiple concurrent operations happening. I would just like to state that there is quite a little bit of a difference between a thread for concurrency, concurrent execution. There is a difference between a thread and an asynchronous, blockchain operation. In asynchronous blockchain operation, it is single-threaded. It works on the current thread. It doesn't create a different thread, and it has to wait for one step to be completed before it hands over to the next step. Okay, so that is where you have this old keyword of await, because there has to be a completion of this before it jumps into this. Meanwhile, a thread just executes all those things together and it works from the OS level. So it's managed by the OS, and it can run on different CPU cores, you understand? So this is if you want to work on multiple threads at the same time, but this is if you want to work on one thread, which gives you control on how which operation should be completed before the other. All right, so that's the major difference between asynchronous functions and thread functions, you understand, in blockchain operation. I mean in Rust, you understand, for blockchain operations. The next thing, we want to work on parallel examples, parallel async examples. So let's look at this. Come here, close this. So write this function called, it's also an asynchronous function, okay? So you can, while async function only helps you to operate one thread at a time, you can run parallel async operation using this technique that is available, in this Tokyo.join, Tokyo join feature. So let's say we have another function called blockchain task that takes in, is an asynchronous function, private asynchronous function. It's a blockchain task. It takes in an ID and the duration that you want that particular task to run, and then you can say that this operation has started at this time, waiting for certain number of seconds, and then you sleep for that number of seconds, which is a duration, and then you say that particular operation is completed. So that is just what this function does. And at this point, you want to say let this task 1 is equal to this blockchain task. It's a function, and you want to pass in the ID of this is going to be 1, this blockchain task, and you want it to last for about 2 seconds, and you want another task called task 2, and you want its ID is 2, and you want it to last for 3 seconds, or I could say 4 seconds. Save that, and you can then call on Tokyo join. There's a method. This Tokyo has something called join that is helpful to execute multiple or parallel asynchronous functions together. You can see how we did not call this await function here. Okay, that was intentional, so that we can execute them together at this point by saying Tokyo, which is this, right, this library, and then you call on join method. Okay, so this join, what it does is wait on multiple concurrent branches, returning when all branches complete. The join so it basically waits till all those various branches are completed before it returns, okay. So say the join method, and the task that you want to join together is task 1 and task 2. Okay, so you want to wait for that to complete, and once it is done, you can then print that both blockchain tasks are completed. Okay, so you run that, and so you wait for this parallel operation. It's an asynchronous one. So let's save this and run this. Running, you can see blockchain tasks, these two have started, and you can see how one took 2 seconds to complete, and then the other one takes 4 seconds to complete. Okay, so that is how you can run parallel tasks together. It's also very much cool, but if you want to run a truly multi-threaded application, then you should consider invoking threads, okay, because threads are much more designated for such kind of task, like you can see here. Okay, there come a time where you may want to communicate between threads. Okay, so if two threads are running parallel with each other, you want to be able to communicate with them. You want them to communicate with each other. So that is where channel comes in. Okay, so let me show you how you integrate or utilize channels along with threads in your application. So suppose we have, okay, let's say we have a tuple. Let's just destructure channel. In destructuring channel, let's start with this. Okay, we have something called MPS, and it's MPS. Okay, this one here, MPS C, and then you are targeting channel. Okay, and in this channel, okay, so this is channel right here, but you want to give it a type of, this is a library that is used for channel. It comes, it's available in this standard library. I think it's also available in this Tokyo library as well, like we can see from those prompts that we were given by the IDE. So this channel, you want to give it a type of string. Okay, and you want to assign this in a variable. This variable, we want to destructure it because it is actually a tuple. So you want to destructure it. This is TX and RX, receiver and transmitter. Okay, so this will transmit message and this will receive message. Okay, so that's what is happening. This is like uplink and downlink. You understand that? So that is what those two means. And you say let handle, just like we've been doing before, with previous setup. Let's copy this line of code. Okay, I'm gonna copy this line of code, which is the handle. Okay, and we're spanning in a new thread, and make sure we have move because they are both going to be interacting with these variables that are outside of their scope. So you have to put move to make sure that ownership rules are not broken. And inside of here, you want to say let messages. Want to stack some messages. It's going to be vector. Sorry, it's going to be equal to vector, and we want this vector to be a string, from, so this is block 1. I want to do that for 2 other blocks. Okay, so this is block 2 and this is block 3. So this is a vector, a vector of strings, you understand? So these are messages, all right? And then for each of those messages is an array. Okay, is a vector, we're looping through it. So for message in messages, we want to send the message. Okay, so I want to say tx, right, dot send message. I want to say dot send, passing this message, and call on the unwrap. This will send the message, okay, to, sorry, I'm supposed to use this double channel here. Okay, so I think that is why I wasn't having this intelligence. Now we have this dot send message, okay, and the message you want to send is one of this message, okay, and then you call on dot unwrap function. Okay, so this will actually send message block through the channel. Okay, so it's gonna send it through this channel, right? And want to sleep for 500 milliseconds. So let's receive this message. To receive this message, I'm going to come out of this thread. I'll say for received in messages. Sorry, for received in RX. So these messages that are received. So remember, we have message that are sent are going to be coming from this place, and if message is sent, it's going to be stored here to receive it. So more like a central hub where message go to, and you can listen from this and receive any message or process the message. So I want to say print line, say main blockchain thread received. So we have received the message, say received. Okay, so and afterward you can say this handle dot join to execute this and unwrap. Okay, so in other words, let's look at this again. This is a channel. I mean, this is a thread, and this is a main thread. Okay, this entire thing is the main thread, and inside the main thread there is a sub thread here. So in this sub thread, we define a couple of messages that we want to transmit, and for each one of those messages, we utilize this architecture, this channel methodology of sending message, to send those messages, those text or strings, understand? And we sent them one after the other and waited 500 milliseconds for each one of those messages to be transmitted. And and after it's done, it's basically going to be stored in this receiver, this string that we're receiving, and we can then list out those ones on the main thread. Okay, so that is what happened here. So let's test it out. So I'm gonna duplicate this and see thread with multi-channel. This isn't an asynchronous function that I'll have to wait on, so I'm gonna remove this and let's call that again, run. So you see how each one was received. We can even do this, to make it look a lot more interactive. We can see sub blockchain thread sent this message here, and then see how we received it. Okay, so sent this message. Okay, let us look at that. Run this again. Okay, this one is sent and we received that. Send this one again, we received that. Send this one. So the two threads, they are communicating with each other. You can see how they are sharing that information because of this channel provision that is here. So that is how you communicate between threads. Okay, and another example is, let's want to also look at asynchronous request with return value. Okay, basically in JavaScript that will be a promise that returns a value. So async request with return value. So for example, let's create another function here. So this is another function under the hood here, and this is async calculate block reward. Okay, calculate block reward. In blockchain have validators, and when a validator validates a transaction, they get a reward out of that, maybe from part of the gas fee also. So you see block time, and block time is an integer. Okay, and reward block time, it's not wise for it to be an unsigned integer. I mean a signed integer, so it should be an unsigned integer, and let it return an unsigned integer as well. So this is block time and this is reward rate. So when we're calculating that, we want to print calculating block time, block reward asynchronously, and want to sleep for 1 second. Remember, we have done something like this where we had to sleep for a certain duration of time. Looking for that example, not in basic, not here. Okay, so this is it. So I'm going to copy this line of code. Okay, and want to wait for 1 second. Okay, and then let's calculate that block time multiplied by reward rate. Okay, so this will be the value that is returned. This is exactly the same as saying return. Okay, so don't look at it as weird, but you don't necessarily. So we're saying that mismatch type expected output but found. Remove this semicolon. Okay. All right. So that last statement there need to you shouldn't put a semicolon on it, so that it will return it. All right. So just take note of all those little details. Okay. So at this point, I could call on this function here by saying let result equal to, I call on this asynchronous function, and I pass in two value. This is the reward, this is the block time, and this is the reward, W5. All right, so now this I need to call, at this point you see the return type is actually a future, a promise. Basically it's not being resolved, so I need to await that, and once I do, you can see that it will not give me the real value that is being returned from this function here. All right, so and then I have to sleep for 1 second. Okay, so no, we don't need to sleep for 1 second. Okay, so we just need to print out the result, saying reward of block result of block reward calculation result. Okay, so at this point, let's then call this function in the main. So I'm going to call this function. Let's see how it goes. So run that, say calculating block reward, and you can see the result of the block reward is, calculation is 50, because 10 times 5, that will be 50. Okay, so that is how you get response, get result from an asynchronous function. So that is cool. There's one more example that I want to show you on how to work with threads and asynchronous responses. Concurrency. Okay, how to deal with concurrency. I want to spawn multiple threads, you understand? So let's do a multiple thread example. We've done something similar to this. That will be parallel async example, so where we have multiple asynchronous functions. So let's do an example where we have multiple threads. Okay, so I'm going to create an array, okay, vector that will comprise multiple threads at once. So it's going to be mutable, and we'll call it handles with an S, and we'll say it's a vector, just an empty vector, nothing in it. So for now, so this is unknown, and this is how you specify unknown vectors, okay, in Rust. So now use the for loop for I in 0 to 5, okay, we want to handle, so we want to say let handle, this is us creating a thread, equal to you can just copy what we've done before. We don't need to do everything from scratch. So let's look for an example we've done before that has moved. Okay, this example here. So let's copy this line down to here. Okay, I will then do this. Okay, so we have handle, create a handle, and we're moving something. So we're dealing with record from external places. So we need to make sure that we have that move right there. So I want to print something. Say blockchain node thread. Thread started. Okay, so I will need to specify with this I. Now I think I may have made a little bit of mistake. I'm supposed to make sure that I retain that for loop 0 to 5. So let's save this. This seems to be alright, because come back to this. If I remove this, okay, let's just keep it for now, and let's do a search from millis. So I'm going to copy this line of code. I want to wait for a certain number of seconds here. So I'm waiting for 1 second. Okay, and then I print that this is finished. This is done. So say blockchain node thread finished, and at this point I'll call on this push method. Say handles dot push. I want to put it inside this array here, and that will be this handle right here. So when I save that, I see this error has disappeared because it now has some value inside. So this is how I push in multiple threads, like 5 threads here that we're working with, and at the end of this I could loop through each one of them. Say using a for loop, handle in handles. Okay, then I want to say handle dot join. So I want to activate it, put it into action. Okay, so this will span multiple threads at once. All the threads that are inside here, I execute them all in this line of code. So let's utilize this. Let's pull it into action. So save that. Now let's run this. So you can see when each one of those threads started and when each one of them also ended. It's pretty funny that it doesn't matter, like each thread for certain reasons can be faster than the other thread in execution. Like you can see how 0 was first to start, 0 was first to finish as well, 3 was second to start, but 4 was second to finish, and in fact 3 was last to finish, you understand, and 4 was third, and this time 4 became second, and 1 was third, and 1 became fourth, and 2 was last here to start, and 2 became third to finish. So it's just crazy how threads have their own speed of execution depending on the complexity of the operation. So that is one of the things that influences the speed at which a thread gets processed. Okay, so that is one cool thing. I actually like thread, but and I also really do appreciate asynchronous operations, and each one of them have their own use cases, but together they help you to be grounded in concurrent operations using Rust. So I'm going to do all this thing now, release them all. Okay, and I'll come here and release all this as well.
run that all at once. Boom. Okay, that are all the things we did. Okay, so a lot of operation. Okay, so these are all the operations that we did today, and it's quite fun to have crafted all these things together with you. Hey, so that was fun, huh? I had some fun working on this project along with you, the course and all that. This is not like a core development where we build an application around it, but this is just like a crash course that enables you to get your hand dirty, molding when you're a potter or something. Just get your hands into Rust and how you can use Rust to build, you can understand the Rust language and use it to build smart contract for the various programming languages that offers Rust as their smart contract language. And I would like to mention a few to you, and there are about 10 that I have access right now to, which the most popular ones are Solana, okay, Polkadot, Near Network, which is Near Protocol. We have Cosmos, we have Around, we have ICP, we have AlphaZero, we have Zcash, we have Seal and Aptos. We also have Stellar, Sorobam, which also use Rust for their development. There are just so many blockchain language. And you can't say that like that for Solidity, except it's only on the EVM ecosystem. So if you're going into the EVM ecosystem, you have that. So that's why I would advise you, if you want to be a strong blockchain developer, you should have two languages. Just know how to build with two languages. You go a far way, which includes Solidity and Rust. And that's why I've taken this time to show you guys how the principles, the syntax and all those things, how you can use that to code and actually culture the tutorial or the course in such a way that it mirrors a real development experience when you're working with blockchain, data. So it eliminates any strange ideas that you'll be facing, real. So because all the concepts are very close to how you build with smart contracts. Okay, so, and I have done this course as a precursor to us venturing into various ecosystems that utilizes Rust for their smart contract. And one of the first I want to jump into is Solana. Okay, and a lot of you guys have been asking me about Solana Dapp, and all that. So the previous one that we worked on was the SPL, library. It's not really, building with smart contracts. So this will help a lot of people to come to understand and appreciate, the value that Rust brings in smart contract development. So that is why this tutorial has been released to you today. So now I'm going to, go back and do some other stuff, and then when it's available, we'll bring in some Solana project into the channel. And my name is Darlington Gospel. If you have not subscribed, for this channel, please hit that like and subscribe button, smash that notification bell, and expect great things coming into the channel. This is where we help Web2 developers transition into Web3 development. Okay, and if you have any question, you can drop in the comment section or on our Discord channel. Okay, I'll see you in the next tutorial. Bye bye.